the classes have been full, so we've decided to run that every first Saturday of the month until we don't get any numbers. But at the moment, the numbers are still sitting quite high. I think, Dudley, you've been on. You've been on the cabinet building? Yeah, so some of the guys have been on, and I recognize you. Okay. So that was on Saturday. So then we're doing introduction to routers. And then, of course, next Saturday, it will be the Hardware Center Winter Expo on the 26th and 27th of July. So it's where they've got all the tool manufacturers and vendors and whatever. They'll be out there demonstrating their kit. So Bosch, Metabo, Craig, and so on and so forth will all be here. So something to come and have a look at. So it's not a it's more an informative session. If you're looking at buying a particular product, maybe a miter saw or something like that, a compound miter saw, there's a couple of brands that are going to be represented. You can go and have a look at the machine and maybe ask the guy some specific questions, which is better than having to walk into a box store to try and find the equipment, and then nobody, you know how it goes. You ask the guy, how does this, the compound miter? No, we don't have a compound miter. And you say, okay, all right, I've lost the argument, and you walk away. So maybe that's the forum to come to just get yourself. And there'll also be demonstrations and so on. So please do have a look on the emails that get sent out to you and what the programs are, what's on offer, okay? All right, good. So before I knock off, is there anybody that has anything to say or wants to add before I get going, or want to tell me about or talk about anything? No, good, okay. All right, so the first thing that we need to always consider, and I'm a safety nut, so I really take everything into consideration. I'm not showing you my hands like that for nothing. I really, really do take my safety very seriously in the shop. So at all times, we wear safety shoes, and at all times we've got our hearing protection on, and at all times we've got our eye protection on, even if I've got glasses on. Okay, so sometimes I might even go to 3 if I'm working on a lathe and the wood's exceptionally hard and it chips and breaks. Then I'll have my glasses, safety glasses, and a shield over the front of that, okay? Because anything can happen. The chips hit at the back of your forehead and they kind of fall down in front of your eyes because sometimes the glasses move down. So you want to really look after yourself. So let's just have a little chat about your PPE, okay, before we move on. And it's something that I would urge you guys to really, think about when you start working in the workshop. So first of all, and first and foremost, is your eyes, okay? So not many things you can do if you don't have your eyes with you and they're not around. But I've heard of exceptions where there's a guy I've heard of that can do turning on a lathe. He's a blind guy. So yes, there's some interesting things that go on out there. And I think anything can be done. But I'm certainly sure it would be easier if you had a bit of vision, that you can see things. It would make life easier for you. So eyes, please, okay, please have a look at that. If the argument always comes up, yeah, but I wear glasses. But we live in a modern age. You can get over the eye safety glasses that you can put on. And they fit quite comfortably. So I have a pair of those that I put over my glasses that I work with. Also make sure that your own glasses are safety glasses to a certain degree. I think it's polycarbonate. So make sure that they have that. So you have one set for the shop and then one set that you wear everywhere else. Because they invariably do get scratched and messed up over a period of time. So make sure that you do that. And if you do feel that it's still a little bit too cumbersome for you, there's a couple of companies out there that will actually do a script and put it into a safety glass for you that completely seals onto the eye with little vents and so on. And I've got a pair of those, but it's taking me some time to get used to them. It's like my field of vision is almost tunnel vision. It gets restricted. And I like to have good peripheral vision as well. Because you're working and I want to know what's going on around me. And these kind of restrict the peripheral vision. So that's a little bit concerning on my side. But I'm getting used to them. I try them about an hour a day. And I think eventually I'll get used to them and start wearing them properly. Okay? So that's the eyes issue that we've spoken about. So the next one is the ears. Now, with regards to a router, you get routers and you get routers. Okay? So when you move towards the lower end of the market, it screams like a banshee. And when you go up into the high end of the market, they whisper quiet. And I think you would find that pretty much with most woodworking tools that we have. So if you look at a table saw, if you had to take a DeWalt table saw, the contractor saw, and you put a piece of wood through there, it screams like it's on steroids. But if you get yourself one of these nice bigger machines that have just come in from Axminster, and they switch that on, all you hear is just the wind rushing from the blade. That's how quiet these things are. So when you put your piece of wood through there, it's going to make a little bit of a noise. Obviously, you're trying to cut that wood, but you could really do without ear protection when you're working on those machines. That's how quiet they are. So, but then again, that doesn't give you a reason not to use your ear protection. So routers, for the main part, and for the most part, are noisy, okay? I've got a really nice big Bosch kit, and it's incredibly quiet. So it's actually misleading because when I work with it, I sometimes think, have I taken the cut? And I've actually got to go back again and have a look, and it has taken the cut because the vacuum system is very good on it. Plus the noise factor, you can't hear it cutting into the wood if you're working with a half-inch bit. Now you're thinking half-inch. Yeah, we got different sized bits, and I'm going to discuss that with you. But it's so quiet that you really have to take a second look to see if you've actually done something. So that's a pleasure to work with. But then your quarter-inch ones, which is the normal average one that you guys would all be working with, those toys make a noise. And you know what? In a way, it's a blessing because the noise will tell you what's going on, okay, especially when you're working with the wood. You know, if you have a knot on the edge of your board and you go through it and then it suddenly changes its pitch in terms of noise, then you know you're going through that knot. You know, so there's always signals, there's feedback coming from the machine. The bigger machines, whilst they've got power and they can do things quietly and easily, they are less forgiving because you can't actually understand if anything's going wrong with them. So the signals that are coming back and the feedback, but then again, you don't really need it because the machines are so powerful and so sturdy that it does the job anyways. It does it successfully. So, but the main part is ears. Gosh, please look after your ears, okay? So ear defenders, and there's some brilliant ones out there. Get one with a, you know, with headphones that maybe play some music and stuff like that. I'm not really the kind of person that wants to listen to music or a podcast while I'm working. I need to stay very focused on things that I'm doing. So I'll have a radio playing in the background, okay? So I'll do that as opposed to, but everyone's different, okay? Everybody adapts differently. Right, so the next one is a very sore topic. And it says very simply nose and lungs. And I mentioned nose in particular. Woods, for the most part, are toxic, okay? There's none of them that are medicinal, not even the camphor tree, okay? So if anybody comes along and says, you know, this is going to be good for your health, wood's toxic, okay? Not to the point that they'll kill you, but they've got toxicity levels in it. And when they turn into dust, so the bigger pieces of dust, the chips and stuff, they come off your router. You know, you can't get that through your nose and into your lungs. It's not going to happen. But the biggest concern is the fine micro dust particles. That's the dust that you don't see. And if you're busy working in your workshop, I'm going to urge you, you guys have got your little portable battery-operated lamps, that mag lamp or whatever it is that you buy from one of the stores or whatever. Take that lamp and put it on the table after you finish routing and just shine it and have a look at the cloud of dust particles that's floating around there. That's the stuff that's going to kill you. Nothing else. That's going to kill you. So the first thing is it's entering into the lungs, and you won't feel it during the course of the day, but when you're in bed at night, you're going to get that tickle in the back of your throat, and then it's going to start working on you, okay? And over time, the stuff settles, and there's a lot of complications that creep in, and I don't want to go into the sort of details of that. But the one thing I do want to mention to you is that there's a new form of cancer that they've just recently, when I say recently, about 3 years, that they've discovered. It's nasal cancer. And the woodworkers are the highest percentage that suffer from that. So, for example, last year and this year, there were 3 editors of different, very well-renowned woodworking magazines that passed away due to nasal cancer. And that's purely just from the micro dust particles that are floating up in the air. So in those days, they tried to filter out what they could see. Nowadays, we need to filter out what we can't see. This stuff is prevalent. It's all over the place. So, you know, we're in the habit in my shop. You know, these COVID masks that they made, those, you know, remember they had the blue ones and then they made them with pink and black and whatever, the little strap around your ear. Look, it's not the perfect filtration system, but if it's there to kind of just mitigate a bit of a virus or something like that, this will definitely work for the microparticle dust. You can pick those things up 50 for $30. So go and grab a couple of packs of these things and stick them in the cupboard in your shop. And whenever you need one, take them out and use it. And for goodness sakes, when you put the thing down, turn it with the blue or the black or whatever side facing upwards, not with the white side or the inside facing upwards, because you put that back on and all the dust that's settled on there, you're just pulling it back in again. And if you keep wearing your masks, you will be aware of this, because on Thursday, I remember this clearly, I had my mask, I did some routing, and I picked the thing up and I put it on. Immediately, the dust was coming in. I could feel it. So you know what? For that cost, what, a couple of cents, 50 cents, 60 cents for a mask, whatever it is. Throw it away and get out a new one and put a new one on. I think it's worth it in the long run, okay? So please, so oak in particular, I have my comments on oak. It's a beautiful wood, I must say. It's hard as granite on the end grain. It's stinky feet when it's getting cut, and it smells like boerewors when it gets lasered. So it's an incredible wood. I mean, we store whiskey at mine in it, so it's a magic wood. But that stuff will kill you, okay? Seriously, it will kill you. That stuff is toxic when it hits your system, okay? So again, you learn these things. So maybe just a little bit of hint for you. If you're working with tambuti, which is one of our local species and our most toxic woods, it's well known amongst the local folk that if you go to a braai and you take a couple of shavings of tambuti, you throw it into the braai and you don't like your mates. Look, it's a good laxative, okay? It'll work. Definitely, that won't kill them. But be careful. The stuff's toxic. Get a splinter, it's going to fester. It's going to do all sorts of horrible things on you. So, a little bit of caution. So a little bit long-winded on the nose and lungs side of things, but just an awareness to bring you up to speed to say to you, be careful. The big chips are not going to get in there, okay? So smaller. Take seriously, if your kids have got a laser or you've got a laser, shine that laser and have a look and see how it's going on in that shop of yours. Okay, you're going to be quite marvelously surprised. Feet. Okay, all right, so feet. For the most part, we're working in the shop. You're thinking to yourself, well, why should I worry about my feet? You're wearing your flip-flops or a pair of sneakers or whatever the case may be. I see this all the time. No, it's okay. The problem is that a piece of solid wood falls off the table and it hits your foot. You're going to know about it, okay? You really are. So at the bare minimum, a set of nice thick leather shoes that are comfortable for you to stand in, that's the way to go. Or a pair of safety shoes, and there's nothing wrong with it. I mean, if you're worried about or you're safety conscious, then go to any of the stores that sell safety kit and go and have a look at the range of safety shoes that they've got. One thing I would like to advise you though, look for a pair of shoes that you can stand in for a while. Okay, I stand practically from the time I get into the shop until lunchtime, which is 12 o'clock, and then 12:30, that's when I sit down, and then I'm back up again right up through to the end, okay? So if you don't believe me, you can come and have a look at my watch. It's well recorded on my watch, my standing. So those little standing rings, I close them about twice a day, okay? So it'll give you an idea of how much standing I actually do, all right? So, and your feet will get used to it if you've got good shoes. So make sure you've got good, comfortable soles on them. Rock hard, cheap safety shoes, going to cause an issue again. If you just invest a little bit in them, they're going to give you the rewards and they're going to give you the return, okay? So a good, nice pair of good, soft gel shoes are going to do the trick for you. So I generally have like a white or gray sole, because if I happen to go to a client's house, I don't want to walk in with black soles and leave black marks on their beautiful porcelain tiles on the floor, you understand? My clients love me for that. They say, oh, this guy doesn't even mark. Oh, he brings a vacuum cleaner. They think I'm like walk on water when you walk there. He's got a vacuum. I've even had a client saying, would you mind just doing the kitchen for me quick? I thought the cheek of it. So I'm not a kitchen fitter, by the way. I was just doing a little piece I had to fix up for them. But that's how you behave. You do things properly. So please do consider that. And then the other comment I want to make, I said steel cap shoes. The steel cap has got a bit of a drawback. In winter time, when you sweat in your feet, the condensation goes up into the steel cap, and the steel cap then obviously it sits, and then your feet get wet and cold and soggy, okay? So you can get a Kevlar cap, okay? And the Kevlar doesn't let the condensation come through. So when you take your shoes off, your feet are pretty much dry. So for winter time, I mean, we all know that winter's kind of really bitter, especially in a workshop. I mean, my workshop at 5 o'clock just plummets, even if it's warm outside. I can go all the way right down to 5 degrees again. Then it's game over. No gluing, no varnishing. I can only do handwork and keep myself warm and that, whatever. So the floor is freezing. So you really just don't want that. And you know what it's like. If freezing cold comes through your feet, goes up your legs, it's an uncomfortable thing. And you don't enjoy what you're doing. So a little investment in that regard is going to save you and make it a pleasure for you, okay? Right, hands. Okay, so there's the protection for gloves, leather, cut-proof, disposable. Okay, I just put it up there because I don't want to enter an argument. But all I'm going to make a comment about is that the majority of accidents that I know of, and that's from personal friends or people that I've met or whatever, every single one of them have said to me, if I wasn't wearing my gloves. Okay? Remember, you got your gloves on. Whatever blade that glove comes in contact with, that blade grabs that glove. And whatever inside that glove is going to go with it. And I've seen horrible messes. I honestly have. You will not imagine. There's one that I just cannot wipe out of my head. I just cannot do it, okay? And it was all due to a glove, okay? And then again, I'd rather have a nick on my finger than lose my whole hand. I can assure you that. So please, the only time, I have a set of gloves in my van. The only time I use gloves is if I go and collect timber from the timber yard. Because I don't know if the guy who's carrying the stuff knows how to carry it properly and he's aware that I'm helping him. Because if he happens to stop suddenly and I'm carrying and I move forward, well, that's what's going to happen to me. So I will wear gloves in that instance. But otherwise, for everything else, no. I mean, you'll learn, you'll evolve. When you're busy touching the wood, you will go with the grain. But if you just freshly planed and edged your wood, you're not going to touch the sides up and down because that's razor sharp in some cases. And it may even have splinters. You'll touch it across. So instinctively, you start rubbing across it. So when you're laminating a table, you don't go up and down the joints. You'll go across the surface to feel if those joints are flat. Do you understand? But you'll work it out. So as you move along, it eventually gets to a point where you may have, in my case, I get about 4 or 5 serious splinters a year. Okay? When I say serious, they've gone in that when you pull them out, a little bit of blood will come out. Okay? There might be worse than that, but I mean, that's nothing in my book. But then you always have the necessary kit to look after you, okay? Right, then the other comment is aprons, either leather or cloth. Aprons are great in the shop. They obviously going to protect you. And once you, again, it's one of those things that you either get used to straight away or you feel a little bit uncomfortable, but persevering will win the day again. And then eventually you'll find out, your apron becomes quite nice because you can put your tape measure in it, you can put a pencil in it, and a couple of other odds and ends. And then you see some of these guys on these other social media platforms, and the guys have got 150 little pouches all over them. They look like they're going off to war, their little pouches and whatever the case be for every little bit of kit. I mean, the guy's a walking tool bag. So if that works for you, then by all means do that, okay? I don't really wear an apron. If I'm doing turning work, I'll wear an apron, but otherwise, very rarely I'll put one on for any other reason, okay? You're not going to wear your best clothes in the shop anyway, okay? Then keep clothes tucked out so the dust doesn't come in and, the rest of it, okay? Sorts it out. One thing with an apron, if you do wear it, please, chef's knots are not going to work for you, okay? You want to tie the knot in at the back. Just remember, it's a simple mistake that happens. Once that piece of knot or tie gets caught in something, it's at 18,000 RPM, and it just swallows it up, okay, until it jams. And if any of you can get in there, it'll take you with it, okay? So, and it's simple. I'm busy sanding a block of wood with my Rotex, and I've got it sanding. It's a little bit overhanging. I've got the dogs in there, and I'm bumped up with my hip. I'm busy sanding, but you don't look at the sander. You're looking at no pigtails or anything coming up. And as it comes down, I had a sweater. Middle of winter, I've got a sweater on that I just put on that's hanging down. Didn't tuck it in. As I'm getting it, the next minute I feel a tug. Yeah, my Rotex is swallowing my sweater. But I managed to get the thing switched off. I'm more worried about the damage to the Rotex than I am to the sweater. So it was a good day. I survived that. Okay, does that all make sense to you? A little bit long-winded, but it's just worth the effort, okay? All right, so that's the safety first. So please, I'd urge you to be cognizant of what you're doing in that, okay? All right, it's important, it's paramount. Right, so now a safety checklist. There's 2 of them, and I want to go through them with you as well. And like I said, it's a bit of theory. It's a little bit long-winded, but let's just think about it and see what we've got to extract from this. The first thing is, have you read your owner's manual? Why not? Everything you need to know about your router is in the owner's manual, including some safety things you need to be aware of, including of how you should handle it if there's an electrical fault. That's all described in your manual. And of course, whenever you purchase your router, you guys will get the box. And in the box will be some funny little looking gadgets, depending on what size router you buy. You've got little things that you can clip into the router with little things that protrude and little edge thingies and little rods. And you look at all of this and say, oh. You chuck it back in the box. And then you want to cut a circle, and then you say, oh, I'll go buy a jig. I'll spend another 3,000 Rand and buy a jig, and I'll cut the circle of that. And then one day in your total boredom, especially after having met me, you go back and say, maybe I should look at the manual. And then you read it and it says, included in your router box, you will find the following: a circle cutting attachment. And you look and you say, no, you're kidding me. And then you say, well, where's the circle? Now the journey starts. You're trying to find your box with those parts in the box. Because inside that is now your circle cutting guide. And some of them have got that for you. They've got edge cutting guides. They've got laminate trimming guides. They've got a whole bunch of kit in there. And you guys are just not paying attention to you. Getting it and say, oh, don't worry, I want to get going here. All right, so please, you must remember now, woodworkers are, I think, we're pretty smart people. You've got to know our machines. We've got to know how to read. Okay, let's start with that. Then we've got to know all the machines that we've got and how to maintain our machines and how to fit things to our machines, how to keep them clean, how to look after them, how to work with them, what they do, what they can't do. We've got to take all of that into consideration. I haven't even started talking about the wood or the finish or the sandpaper or anything else that goes with it. So I think we're pretty smart. I don't know how you feel about it. I think we're pretty sharpish people. Okay, so read the manual. Some oaks sat down and put that together. Gosh, I ain't got paid for it, so please make use of it, okay? Make sure you selected the proper bit for the job that you're about to perform, okay? Now, it sounds like a bit of a vague statement, but no, you need to go and make sure that you get, for the job that you're intending to do, that you selected the proper bit and that you're going to do it fit for purpose, okay? You're not trying to do something with a bit that's not suited for the job and you're going to try and half measure this thing and hang it over the edge and then slowly and go whatever. Yeah, make sure you got the right thing because anything that doesn't fit and doesn't work properly is going to cause a problem or even an accident. Make sure the bits, the clamps, attachments, and locking devices are secured before starting the router. Please make sure you do that. First things first, when you do your fitting of your bit, make sure that the bit is locked. Well, you should always inspect the shaft of your router bit to start off with. If there's any wear marks on it, it's going to tell you that there's something wrong with your collet, that your collet needs to be attended to. And generally speaking, every sort of 6 months, you should be, in my case, we replace collets because we wear them out. You know, you've got this hard steel and you've got the collet that has to clamp over it. So you'll pick it up. You'll get the signals coming off from the bit. It'll tell you what's going on in terms of your machine. Also inspect everything. Make sure that your collets and everything are clean and tidy and that everything's working properly. And then clamp it up. Make sure it's clamped properly. You don't have to over-clamp things. Just give it a nice nip and then it's nice and tight inside the machine. Make sure that the clamp, your piece that you're working with is clamped down. Okay, and it's clamped down properly. Do a walk around. Do a dry run with your router. If you've got an odd shape to do and you've got to clamp it on the table so a piece is overhanging, clamp it there, and then work out what you're going to do. Work out your path. Do a dry run on it. Walk it. Understand how you need to move. You're going to go round, round, round. There's nothing worse than starting here and then going around something and then realizing, oh, heck, I've still got to go all the way around. I've got to come back here. And now you can't reach over to that side. You should have started there, walked around, come all the way around, and ended here. Do you understand? So plan what you're going to do. So make sure everything's sit, clamped down, locked down, and make sure you do a dry run. The same as we do a dry fit before we glue up. It's the same thing you need to do with your router. In particular, not many other tools you need to do that with. Table saw you don't have to. Miter saw you don't have to do that with. Jigsaw you don't have to do that with. Planer, thickness, or joint, or whatever you're using, you don't have to do that with. But definitely a router. You've got to do a little bit of a, how am I going to do this cut? You need to plan it, okay? Especially on bigger sizes and stuff like that, okay? All right, so make sure you've got that kind of worked out in your head. And there's a lot of other little things that come into play, and I'll also discuss it with you. All right, now, I know some of you guys have inherited routers from your dads or maybe your grandfathers and stuff like that. Awesome, very great. And I know you're sentimental and you want to use it and it still works and all of that. Major, go for it. But just remember, those machines aren't like modern machines with the trigger switch is in the handle. So when you're not pressing it, it's not on. These older machines have got, and the cheap machines have got a little switch on it that it goes on or off. Yeah, we can make it available afterwards. Okay, all right, send the PDF. So it's got an on-off switch. So if you have a look, there's a Makita router there on the table. There's a blue Makita router. Very simply put, it's only got an on-off switch on it to fire it up, and it's got no speed control. So it sits at, I think it's about 18,000 or maybe 22,000 RPM. So that's a lot of speed on it. That's ideal for a dovetail configuration that you want to work with. That's perfect for that. Like, that's why they design them, come in at a very good price point, low price point, good machine, single speed, on-off button, no frills, no fancy stuff for your dovetailing. Okay, so that works great because it's a half-inch router, by the way. Okay, it'll take a 1/4 inch as well, but it's primarily a 1/2 inch. So that guy has got a lot of torque on it. When it fires up, it will actually jerk when you switch it on. The problem is that if you've got that on the table, or you've got a bit in it or something or whatever, forbid what you've done, and you plug it in, that thing switches on. You know, then you've got to get to it quickly or whatever the case may be. So, and it's heavy. So even if you try and hold it in one hand and plug it in, and then it gives it a little bit of a jerk and a twist, and then you know it's alive, then you've got to go and get it switched off. So the point to make is make sure the router is off, okay? Even when you've got your little toggles that you click in and lock, make sure, just give it a click so that you know that this thing is loose. And I do that all the time. It's just a safety thing. I don't want this thing firing up in my hands, okay? Also, another thing is if you're working with your router, if you need to set it, set the depths or whatever the case may be, fitting the bits, my goodness, make sure it is unplugged, okay? Anything can happen, all right? Anything can happen. And when it happens, you turn around and say, oh my gosh, how did that happen? You think, I can't explain what happened. Well, there you go. That's anything. It's just happened. All right, so keep the thing unplugged and only plug it in when you're about to start the job, okay? That's what it's all about. Right, grip the tool tightly, particularly on startup. There's nothing wrong with that. And the reason why we say that is you go white knuckle when you hold it. It's the safest thing you're going to do, okay? Because when you're holding it, you may have inadvertently put it up against the piece of wood. And my goodness, if you start the router up against a piece of wood, you are going to know it and you'll never do it again, okay? All right, so hold it white knuckle. And if anything happens, just always pull it back towards you, okay? It'll reduce whatever's going on, okay? Or stop it or prevent it or whatever. But hold it tight when you start it up. I do the same thing. Hold it tight instinctively, and then we get going with the job, okay? So please make sure that you do that. Right, so then for the checklist 2, aprons, we discussed that. Leather cloth, dress properly, no loose stuff, okay? I mean, I told you a story about my sweater, so please. Right, the other one. For those of us that work from little workshops at home, okay, where the grandkids come around and there's dogs and cats and whatever the case may be. Again, you see it on social media. You've always got to see the guy showing you an image of his dog or his cat or whatever. Cool. I'm okay with that. I won't do it myself, okay? Make sure that you've got some form of a signal that people stay out of the shop while you're busy. There's nothing worse than you're seriously concentrating. And I need to tell you this. You get nervous sometimes you've had perhaps a mistake or an error that happened earlier on. So it's not unlike a bit of trauma that you experience because, you know, we're craftspeople. So you make a mistake and then you get annoyed with yourself because now you've got to go and fix this mistake up, which is always fixable. Most of them are fixable. But the point is that you're trying to do something. You've done it before and you had a mistake and you're saying to yourself, please, because routing is always just about the third last step. So routing, final cleaning up and sanding, and then finishing. So it's the third last step on your project. And it's not the time you want to make a mistake, okay? So you do. You get a little bit tense and worked up. You're highly focused and concentrating, and now you start. And then somebody tugs on the back, and you think, oh my goodness, your whole body and brain just reacts as though this thing's going wrong in front of you because you're focusing there. And that can throw you out and throw you off completely. So just ask everybody, leave me alone, or do like we do. Okay, and put a sign up or something. My mates in the States, they have little signs with these little plastic chains. They put a plastic chain up with a sign on the kids actually sit there and stand and wait until, you know, granddad's finished, and then they can go in. You understand? So if it's that discipline, great, you've won the war, okay? But please, all right, even your dog under your feet is enough to cause the calamity. I mean, I've got cables and wires around me here, and I've got to be cognizant of it all the time. Imagine now a moving dog and cat. Even worse, so don't get too involved in that. But anyway, you manage your environment. We've discussed it, okay? Right. Make sure 100% the bit is not in contact with the workpiece before switching on the router. Okay, so I've discussed that for many reasons, okay, because that'll just create a disaster. Put the machine down. You never look at the bit. If you're staring at the bit, I don't know what you're trying to look at. The bit's not going to go anywhere. It's always going to stay in the router if it's tight. take the router and you put it down, you leave it on, you bump it up against the edge, pull it back slightly, start the router up, comes to full speed, move it back onto the piece, and then you ride it. When you get to the end of where you are, pull it back slightly, and then release. That's it. And that's for everything that you do. Don't leave a bit sticking out. Don't lift it up and then have a look. I've watched people pick it up, because I train router classes here. They pick it up and then they go and I think, oh, goodness gracious me, and the bit's going on crazy in front of them. And I think, okay, only a matter of time. What more can I say? So please just be aware of that. It's probably one of the safest tools in the shop. It's only you that's going to cause the tool to be unsafe. Okay, so follow the instructions. Do it properly, and it'll all be good. Do not force feed your router in any situation. Okay, so you want to route this edge. First of all, have a look at this edge, and I'm looking at it now, and there's a knot about there, and a little something of a knot on the other side. Now I'm aware of it. So now I start the routing process. I route. And when I get plus minus there, if you're not sure, you can also just drop a little chalk mark or a pencil mark. So it'll tell you that's the knot. So when you get there and the sound changes, look at your line. You say, it's my knot. I've hit my knot. Then go over it. Don't come back and say, what is it? And then try and have a look and then realize, oh, no, it's the knot, and then go forward. No, be aware of what you've done up front. And then you measure it, and then off you go. Okay? Mitigates your problems. But if there is anything that's wrong, and you're working, and then you're pushing, and you feel it's a little bit harder, you shouldn't be pushing things through. You should let the tool do the job. It should basically float through whatever you're doing. If you feel that you're pushing it and it's making a noise, back off and have a look and see what's going on there. And sometimes what happens is knots can be inside the wood that you don't see. And now you hit this particular knot. It's just at that angle, and then that's what's causing a bit of grief for you, okay? Or anything. Maybe there's the cable's too short, and you're busy trying to push that. Meantime, it's your cord that's busy pulling you, okay? So there's a number of things that could be causing that problem. Switch the machine off, and then dry run to see what's causing it. Sometimes you may even find that you're standing on the cord, and you're trying to push it, and you've now locked it, okay? So just have a look and see. So you'll become aware of this and realize, you know what, I'm getting frustrated with this. So then you build a little thing that will hang it from the roof, and then you put your vacuum hose from the roof, and then you say, I should have done this when I first started. And then life just becomes so much more easier, and it's much more pleasurable. Okay, switch the router off immediately at the first sign of any unfamiliar noise or vibration. So in particular, if it starts vibrating, then switch it off. Something's not right. And I've had occasions where they make router bits, and we'll discuss that as well, where the bearing actually disintegrated on me. And the bearing itself made the vibration on the router when that bearing fell apart. And that created the vibration. So when I looked up, I saw this knurled up bearing, for the pilot bits that you work with, or the bearings that you have, just totally disintegrated. So things happen. So you've got to just be aware. It's not an end of the world. It happens. You go buy a new little bearing and put it back on again. But it's so expensive, and they're normally the things that survive. Right. Then the last comment. I don't know how you work in your shop. In my shop, Dudley's been to my shop. Anybody else? Dudley's been. First thing the guys will tell me is, gosh, your shop is clean. My shop looks like a mess to me. But my shop is clean. The floor's always clean, because the dust and the chips and stuff on there are the things that make you slip. They're my tools. Whenever I'm finished, I clean everything out. I've got a nice little blower. I blow all the dust and everything off it. I take the bit out of there. I make sure that the bits, I look at the bits, got a little brass brush. I clean all the rubbish and the gum that might be on the bits. And if it's too hard to get off, just put it in get a little tub, a hand cream tub. When it's finished, then put some clean green in it and just drop your bit in it. Leave it for about an hour, come back. And all you have to do is just wipe it with a cloth, and the job's done. Okay, it's clean. The gum and the pitcher's off the thing. It's good and ready. Inspect it to make sure it's got no pieces that are missing on it. If there's a little crack or chip in it, then you need to make an assessment and say, all right, it's not going to affect me. As long as the other one's fine, this one will have a little nick on it. The other one will take the little groove out for you. So you're okay on that. But if it's a nick on both of them in the same path, then you're going to have this little groove wherever you route. So then just throw the thing. It's not worth keeping it. Okay. So go through it. Then I go through my router. I inspect my router. I clean everything up. I check the collets. I take the collet out. I clean it up properly. I take the cord. I take a damp cloth. I wipe the cord down. And while I'm wiping it, I'm feeling the cord, because maybe I nicked it with the router. If I feel there's a nick in it, well then, okay. Then we get profaned, get it over and done with, and we replace the cable. Now, put it in your box and pack it away. That means when you're about to start your new project, you don't have to now go and say, oh gosh, I've got to clean my stuff first. Now it's fresh, it's a new project, you're ready for it, and you can go and get full steam ahead and you can get started and get going. Does that make sense to you? So look after your equipment, okay? It's really worth it. It's going to, if you're making money out of it, it's going to return its investment for you, okay? So do that, okay? Right, are there any questions or anything or any comments at this point? Anybody? Nothing? Okay, good. All right. Have you seen that before? What's that? A router. Some people call it a router. Have you seen that? We definitely needed that during load shedding. All right, so let's start off. How did this router come into play? What allowed us to evolve to creating and developing and inventing a router? What started this whole process? Anybody got any idea? How did we get to this machine? No idea. Okay, well, I'm going to surprise you. Yes, hand planes. So they used to do everything with a hand plane. Then eventually they worked out that you could create a rebate plane. That means they'll make a little groove on the edge. Or you could make a little ogee, or a Roman ogee, or a V, or whatever, or a cove. Then they realized if they cut the blade in these patterns, and they could put it on the edge, and they'd run it down the edge, that would make the groove for them. Okay, perfect. And what they would do is they couldn't take out, if you had a 6mm cove bit that you needed to work with, you wouldn't try and take 6mm out in that corner straight away. You would lower the blade, and you would take one lick, lower it again, take another lick, lower it again. So probably about a millimeter at a time until you got to your 6mm depth. Okay. So that is how it went from plane to the rebate or edge planing or for moldings and stuff like that. And then eventually in the sort of 1880s odd, there was a company that manufactured these machines that were pedal powered, and it was incredible because they had a bandsaw, they had a table saw, they had a jigsaw, believe it or not, and then they had the router. And there's a TV series on called The Craftsman. It's an American TV series. And this old man, I'm trying to think of the town. There was a TV series about Eureka. He actually lives in Eureka. And he's got this workshop barn with all the rubbish in the world in there. And seriously enough, he's got that machine. So when I saw that, I just said, this is uncanny. And I actually emailed the company who did the production, and he got in contact with me, and I had a conversation with him. And he sent me some pictures of it. I couldn't believe it. And I asked him so much about it, and we had a video call, and he showed me. It looks exactly like that. And I told him I was from South Africa. I said that it would be great because we can use it. Yeah, we've got load shedding. He said, what's that? I said, no, we don't have power for about 8 hours a day. It's something that we could make use of out here. So that was the first. There you can see the bed. So it's a table router with the bit that's sticking above that would then you pedal and then obviously turn the turning mechanism, and then would do that piece of wood where you put the molding on for you or whatever it is. So that's an interesting little bit of history there for you, okay? All right, so then this particular one. Okay, so Kelly Portable Router. Okay, there were two companies. So roundabout, that people aren't sure. It's one of these things that just the historical fact is sort of disintegrated and disappeared. So round about 1905, 1915, there were two companies that manufactured the first electrical router, okay? But they don't know who's invented it first or designed it first or put it into play. But the one that's the most popular out of the whole lot was the Kelly portable routing machine. Why I zoomed in on this is because I want you to read this. Just read how they marketed this machine. Okay, there's two things that stand out there. What are the two things that you can think that stands out on this description? Okay, first of all, it's electrical, okay, and it's hand-powered. So there's two other things that stand out here. What are those two things? Eh? Yeah, it's fast. I mean, what would take the guy, so imagine this guy's got to do a building, and he's got a couple of meters of cornicing that he's got to do, or dado rail. And now he's busy with his molding, and he's taking off a millimeter at a time. So if it's 6 meters long and 1 millimeter at a run, times 6, times that by time. Now work out how long that's going to take. A router, a half-inch router, can do that in one step. Okay? So fast, but that's not, there was something else that actually sticks out. Operates on the workbench with either 1 or 2 cutters. I never heard of that. 1 cutter we're all familiar with. Why 2 cutters? So when I inquired, I found that the 2 cutters is because of the dados that they used to make in those days for cupboards. They required 2. So these 2 cutters were evenly spaced and they would make the dado with that. So that's basically the groove, okay? The other thing that's interesting, it does the work so smoothly that hand finishing is unnecessary. So if you think of it, you take a quarter round. You know, like in your house, you've got the skirting, you've got the little quarter round at the bottom. When they put that through, the advanced version of a routing or a router would be a molding machine. It's the same concept. When you've pushed that through a molding machine, they don't sand it down. That is as it is, and it comes to you like that. Go to any of the big box stores and go and have a look at all the moldings that they've got. Those come straight off the molding machines like that. So your router effectively does the same thing. If you set it up properly, and it's all set to the correct depth, and you've finished all your sanding, you don't sand after you've routed. You sand everything, and then you route. Because any little dips and dents or whatever that you've got, the router picks it up, it telegraphs back to the router. So you make sure you've got your sanding done. You don't come and sand afterwards, because then you start squaring corners up and stuff like that. So when you're doing a round over, then what happens is you start at one end, and it's true. You just run down and do your round over, and when you come back, you can actually have a look at it. It's smooth as anything. But a sharp bit's going to do that job for you, okay? All right, so, and the guys that have worked with routers can back this up, correct? You do one clean cut with it, and the job's done. You don't have to go and repeat the effort, okay? Interesting. That was now over 100 years ago, eh? All right. All right, now something's just interfered with my presentation. All right, there we go. So types of routers, okay? So listen, that's just a small subset of what exists out there, okay? If we go through the router types that you have, so here's a palm router, okay? Very popular is the DeVault. Got everything on it. You've got the speed control. You can dial it up and down for depth. It's basic. So we use that for small jobs. It's always the little router that everybody gets, the first router that most people would buy. It's a small little palm router. And then they fall in love with it, and then they start overworking this poor little guy, and then they hopefully upgrade. This next one is a fixed base router. This is a port and cable fixed base router. Nice machine. It's got a nice fixed base. Center of gravity is a little bit lower down, so you can put it nicely on the edge. You've got 2 nice handles. You can grab it and go ahead and do your work, okay, or whatever you need to perform. The little DeVault trim router here shown to you with a fixed base and a plunge base kit. So most of the small handheld or palm routers are starting to come out in that configuration where you have the plunge and a fixed base with it, okay? So the small one here would make sense, because maybe you want to try and get into a small little area and you need to just zigzag in between things. That's the perfect use for it. And this one kind of almost doubles up close to something like that, okay? So you can move things around and get a bit of work done. And it's got a plunge, so you can go by different depths. You can plunge down, okay? There's a bigger version of the Black & Decker for their plunge router. And then you can see the Triton. Triton was an incredible design. One of the safest routers that were ever made or manufactured. But the only problem with that router is that the on-off switch was somewhere on the side, if I can recall. I think we might have one here. It was on the side, and it was like a light switch type thing, like an electrical outlet switch. So you had to kind of, once you've got this thing set up, or you've got it up in the air, you've now got to get your hand in there, switch it. And the only thing is, if you needed to switch it off quickly, it's impossible to get your hand into there in time. So for that, it was weak. But for everything else, it was an amazing machine that they put together. And in fact, my one, I have the 2 models, but my bigger one is my router tables router. That's where it belongs, because that machine is strong. It's a 2.4 kilowatt motor in there. So you can push, it's like a molding machine. So you can push whatever you want through that, okay? Right, so there again is the small little Bosch version, Makita version. And I think most people would have come across the Makita little palm router. And if you've probably got one. I've got one. It's in like a cooler bag with 100,000 fittings and jigs and adapters and whatever. And every now and again, I'll take it out just to use a particular thing to work with. They've got some fancy little adapters in there. Even the little plunge, even the little plunge base, it's got all the, you can see some of the little bits and pieces that come in the kit, but it came out like a cooler box style thing with all the bits and pieces for it. Right, there's the Bosch. It's a fixed base, this one, a fixed base Bosch with an edge trimmer on it. There's a Hitachi, or the now known as the Hikoki, I think it is, with their plunge. You can see the smaller ones, plunge and fixed base, and then you can get the Festool with their design. Bosch came out with a similar design to this one. I've not used it. I've seen the guys come and do training here with it. They bring it with. They try it out. I've not tried it, okay. But I've got this one here. So my spindle can go into a fixed base or it can go into a plunge base. And I absolutely, man, I'm crazy about that machine. I've got about 7 routers that I use. Now you're thinking, why would you need so many routers? Well, I can tell you something. When you need a bit to do one particular bit of a job, you set it up properly, you lock it and you leave it. That's going to be used for that alone. Then you need another router to do another thing that you're busy with. And then you need another router to do another thing you're busy with. And so eventually you set up that. I mean, I got to 6 and then I thought, I need one more router. And I thought, no, this is crazy. And I went up into the store, and funny enough, I found a Ryobi that somebody had given. I must have bought something and they threw this Ryobi 1/4-inch router in. And I took it out and I thought, yeah, all right, let me have a look at it. Put it together. You know what? I was pleasantly surprised. That thing did exactly what it was supposed to and worked the way I wanted it to work. You know, when you let the latch go, when you plunged it, it locked. When you clicked it down, it unlocked it. And it's exactly how I wanted this thing to work. So it worked like the Bosch Goff, which is also somewhere, and we'll have a look at that later. But it was the perfect machine. I'm just very impressed with it. There's nothing wrong with it. So if you've got a Ryobi, good on you. You know, don't let anybody come and say, oh, yeah, you know, you're not in my league, you know. If you can do the job with a Ryobi, why not, eh? Who's got a Ryobi? Yeah, there you go. Sorry, you're running out of it. What? Oh, gosh. Folks, just hang on. I've got a glitchies here on my machine. Okay, there we go. Okay. So there we go, fixed base and plunge base router. So this would be a fixed base router, and that's a plunge base. Let me just talk to you about this quickly. This particular router, this is what I got because I wasn't going to wait for something to happen. So in this case, I bought this kit, then I had both options available to me, so I didn't have to worry about anything else. And the other thing is, this particular machine I got all the collets for it. So let me just go through this with you quickly. You get a 6mm collet. You get a 6.4 or 3 something. That's the 1/4-inch. Then you get the 8mm, thanks to Festool. Then you get the 10mm. Then you get the 12mm. And then you get the 1/2 inch. So that's 6 collets that you would need at any time. So I wanted a machine that could satisfy all those requirements. And then I got all the collets. So I've got everything that I need, because one day you buy this particular product and they supply the upcut bit with it, but it's an 8mm. Now you're going to run around to try and find an 8mm collet, okay? Or you go and have a look at something they've got a 10mm. 10mm is as scarce as hen's teeth, but I've got stuff in my shop that uses a 10mm bit. And then you got the 12mm. So the 6 and the 12 was the metricated version made in Europe, until eventually the imperial versions have just dominated the market, okay? Because the North American market is the biggest market, so we get the benefits of that. So anything other than that, it's purely specific to that particular brand, okay? So not knocking Festool, but they should now with Festool, you've got to go buy the collets as well, and those products aren't, and they're not standard collets. They don't all interchange. Some of the collets between the Bosch and other machines will interchange. There's some nice things that they've done that they make that are interchangeable, so it's universal, if you want to call it that. And some companies just want to keep their stuff proprietary so that you can keep on feeding that ecosystem. So entirely up to you how you want to manage this process, okay? All right, but that's, just to give you an idea, that's the fixed base and the plunge, okay? All right, there's a laminate trim router. Okay, so that would typically be the small handheld routers, the palm routers as you would call it, okay? And that would be a laminate trim one. So what you can see on this here is you've got your chipboard, and then what they've done, they've taken that laminate. So you may be familiar with this in the kitchens. The guys would come in and put glue down on the top, and they would put a laminate over the top of it in different colors and shades and whatever. And then there's a bit of an overhang. So this is not exactly the laminate trim cutter. The laminate trim cutter is actually a solid steel piece, but this will work, okay? So you can see it's got a bearing down there, and it runs against the edge of the board, and then it cuts the laminate trim. It trims it down, so it's absolutely flush. And then typically what we do is we just put a 45 degree on it, and just run a little 45 degree across that edge, because that edge is razor sharp. So you can either take a file and just quickly file it down, or a piece of sandpaper, but you stand the risk of scratching the laminate, so we just put a 45 degree on it, quickly run it through. Just puts a nice little chamfer on, and sort of blunts the edge, okay? So that's a laminate trimmer, and I think for the most part, everybody's got one. Who hasn't got a laminate trimmer? Okay, 2 people. Well, there we go. Because it's the first one that you typically would pick up. Because you look at it and you say, oh, I can intimidate this more than it can intimidate me. So I'm going to get this little guy. And you get it. And you work with it. And you overwork it until you realize one day your mate comes past and he brings his route. And he says, give it a bash. Or you go to his place and you try it and you say, gosh, because your confidence levels are where they should be. Now you take this bigger one and you suddenly work with it, and then suddenly you say, I should have bought this thing ages ago. It's doing exactly what I wanted to do. And it works properly. And then you go up to that one. Then you look at the half inch, you say, wow, that's a bit of a big boy. Until you get that, and the things whisper quiet, you say, my word, I should have got that when I started. You understand? So it's an evolutionary. But then again, you've got yourself 3 routers, which you're definitely going to use as you get more complex in your project builds. Okay, so no loss in any of that. Okay, so don't go and quickly sell them off, because guaranteed you'll buy one back again. Okay. All right, let's go and have a look at the anatomy of a router. So for the most part, most routers, modern routers, are designed in this sort of configuration. Okay. So at the top, you would have typically the motor, all right, with the spindle, and then a shaft that would then go through there, and then attached to the collet, and then your bit would be inserted at the collet end. Okay, so it depends on the make. But yeah, they got the variable speed at the top. But typically now the variable speed sits on the left-hand side. You can dial it in on the left-hand side. Then you got handles, so you got handles on both ends. Meaning both hands should be holding it, not one hand. Okay, hold the piece and then use the router. Okay. You've got a trigger, which is on the opposite side of the handle with a little lock button on the side. Now, I never use the lock switch, okay? I just don't. I want to know that if anything goes wrong, I can let go of that little switch, okay? Because if it's locked, you can't let go. You've got to click that little button in. So I don't, that's how I work. There's the collet. Then you've got your depth stops. It's a little set of turret stops at the bottom here. And then your base for your router, which has typically a plastic material at the bottom of it. So if you just give me a tick, let me get a route. I want to just, it's always easy to talk about these things. And then, where's the GOFs? Not one. Can you just pass me that DeWalt machine, please? It's not actually what I wanted to look at, but okay, it'll do. I mean, I'm just going to hand this around. Just have a look at it, just to get an idea. That's the palm router. It doesn't feel like a palm router, but it is. Okay, so it's not the router. We'll have a look in the break. I'll dig one out, and then we can have a look at it. Okay, but that's sort of the basic configuration. So if you look at any of your basic machines, so your Black & Decker, your Crest, your Bosch, your DeWalt, Ryobi, they all fall in the same category, and the Makita so on. And designs are pretty much in that league. So I think if you can remember what your machine looked like, it's pretty much like that. Okay. Just the one thing I wanted to mention before I go, and it's not all that clear, and I was hoping to get the Bosch machine, and I'll show it to you a little bit later. But can you make out what's going on at the bottom here? There's a thing called a depth stop. Can you see that? You'll have on your machine. So the Makita has got it, but it's a very crude system. That depth stop is one thing I think for most people it's a mystery. It's a science. How does that thing work? Okay. So I think what we can do is when I get the GOF, then I'll give you a quick heads up on it. If you know how to work with that properly, your job's done. It's the easiest thing in the world to work with. What most manufacturers do, it's got little steps around it. And each step down is 3 millimeters, and in some routers it can be 4 millimeters, okay? All right? So generally it's a 3 millimeter step, telling you should take a cut 3 millimeters at a time, okay, on an average machine. So that's a 1/4 inch type router. If you use a 1/2 inch, you can go down to 6 millimeter because it's a different machine altogether. More powerful, more sturdy, bigger shafts, no flexing, much better to work with. You can go down to 6 millimeter. So in other words, that saves us time. Instead of now having to do 4 passes, I can do 2 passes and the job's done, okay? So that little turret for the depth stop is the secret in terms of getting this to work properly. So we'll have a look at that separately, okay? And then I'll show you and explain to you how it works. All right, then the next one is the table router. So that is the final evolution where we take our routers to, is the router table. Now, a lot of the things that you do with your handheld router can be performed even easier with a table router. You know, you can set things up, you can do thinner pieces of board and push it through without a problem. You can push it through on the table router. You can do moldings, you can do dados to a limited sense. So most of the things can be done with a table router, except big projects. You know, if you're going to build a bookshelf and you want to put shelves in, you want to make grooves in the sides, the panel's too wide to fit across the table, so you're going to have to do that by hand, okay? But the table router is just a more comfortable zone to work with. It has its little caveats. There are things that sometimes don't go quite as well as what you want. And there's also safety procedures around using a router table. Guys posted a video about 2 weeks ago on a bit that the guy was busy cleaning out for speaker boxes, and it snapped. But man, I tell you what, I actually put it in slow motion to see how close the guy's fingers were to being caught. And all his comment was, I still got my fingers. So yeah, you've got to really work carefully with those things. You can't be gung-ho and cowboy about it. Safety first all the time, okay? But between the two, this is the ultimate. This is where you want to really go to, okay, once you've gone through your evolution and you want to land up on a table router. You got a table router? No? Anybody got a table router? Okay. So that's kind of where you would like to land up, okay, at some point. All right, so we're going to have a look at the next section. That's router tips and tricks. And I'm just looking at the time, and I know a little bit, I think I've gone a bit faster than I should have. So I think I'm going to call time out about now. Let's go and have a coffee break. And then I think before we do that, are there any questions, Jordan? Anything else? Okay, so it's for the presentation. All right. Yes.
You mentioned the quarter-inch router that
Yeah.
makes a lot more noise than the half-inch.
Yeah.
Is the router bit a factor, or is it just the size of the machine?
Just the size of the machine. A little bit underpowered. It's a smaller machine, so it winds. So it's all those factors that get included into it. So the bigger thing, bigger bit, wider bit, a bigger shaft, vibrations absorbed, much sturdier, bigger build, faster, more powerful. Yeah, so mitigates that. Okay. All right, are there any other questions? Anybody? Ladies, anything? Dudley, you're good, eh? All righty. Okay, all right, let's grab a cup of coffee. It's around the corner, so 15 minutes and then we get back and we get on with the next section, okay? All right. Oh, gosh, where is this? Hello. Okay, good. All right. No worries. As long as you're enjoying it and you're getting something, yeah. Okay, good. Yes.
These different sizes of bits.
Yeah.
Do you generally, you buy all the collets, do you get attached them to a half-inch? It's easy, you know, you put it into a half-inch and then you can always downsize with collets on a half-inch, or...
So if you've got a half-inch shank on your bit,
Yes.
you put that into your half-inch collet. If you've got a 6mm shank, you put it into a 6mm collet. So don't use reducers or anything like that. No, those things are generally not classified as safe. Okay, and reducers and extenders shouldn't be used. Okay, we don't use them at all.
Now, you've got, I've got down below here, artwork.
Yeah.
It's the 8 power tool. It's called the power tool, the yellow
Okay.
one.
Yeah.
That's an 8. But then I went and bought myself a palm router and a Bosch, which is a 6. You know, it was just a quarter.
Yeah. Yeah.
I got an adapter for the power tool, the 8 one, to be able to use my 6.
Yeah, it's got a reducer in it. So you put a little reducer around it and then you lock that in. Look, for what you guys do, it's pretty okay. Not going to cause problem. For us, when we're busy with hardwoods, then what happens is the shaft spins inside that reducer and then it causes burning and whatever. So,
Different routers, different sizes.
well, more the collets. Yeah, than the router itself. So we'd rather go the big and then get the collets and then put the proper collet in. Yeah. as opposed to the reducers and the whatever. And extenders, stay away from extenders. You've got major headaches when that goes wrong. Yeah.
Sorry, there is a question for the
Yeah, go.
Okay. So Billy asks, I want to make a dado in MDF with a handheld knife.
Yeah.
Can I do this with one go? Must I do this in multiple passes? Meaning starting with the German cutter and go deeper until I have that.
Okay, so Villy, what I would do is I would start off on the 8mm. I would start off with 2 3mm depths and then do the final depth to the 2mm to make the total 8mm. I wouldn't cut the MDF in one step. It puts a lot of strain on the router itself, and it can also, especially when it comes to MDF. MDF has got abrasive materials in it because of the grooves and the adhesives and so on, and that invariably then blunts the bit. So rather go a number of shallower cuts, so 3, 3, and then 2, for longevity on the bit, and then also for obviously longevity on the router. Okay, so I would do it like that. However, I don't know what width dado you're going to be making, so it would be preferred and first prize if you can get the router bit is the same width, in other words, or at least diameter for the dado that you're going to make. So let's just say, for example, you want to make a cupboard with a 16mm wide dado, then get a 16mm diameter bit. They are available now, and then you can just do one pass. If it happens to be a wider dado, then please remember your rule of thumb. You always need to keep the router onto the side. So rule of thumb, edge of the board that you're cutting and the direction that you're going. So if it happens to be 20mm, you'll have to start this side, make the cut to depth, and then move across to make the cut to depth, if you understand what I'm saying. So please just be safe, and thanks for the question.
The route. I think they're outside. There's a transfer. Hello everybody, it's Jordan here from Hardware Center, just behind the camera at the moment. Like I said in the chat box, we are having a 15-minute coffee break, so we'll be back shortly. Alright, but still feel free to ask questions in the chat box. I'll be available to also try and answer as much as possible. If not, Bunny will answer as soon as we're back from the coffee break. Alright, thank you all again for joining, and yeah, continue to enjoy. We're going to be doing this a heck of a lot more in the next coming months or so. So just make sure to keep an eye out on our Facebook, YouTube, Instagram, all the places where you can find us. If you want any more information, you can contact us at info@hardwarecenter.co.za. And just one other thing that I've forgotten about now. If it comes back into my head, I will let you know. Oh, yes, sorry. The stream will be made available to watch after everything's finished. So you can use the same link that we've posted on our Facebook page or put on our WhatsApp group to watch it after. So it'll be available for everyone to watch here again whenever you need it to. All right. Thanks, everybody. Hi guys, Jordan here again. Yes, just one other thing. We are going to make these slideshows available. If you haven't joined our WhatsApp group already, please do so. I'll put the link in the chat in a few minutes. So we'll most likely put it on there, and then everyone can have a look at these slides after. So if anyone still needs to join the group, please let me know. But I will be putting the link to our WhatsApp group in the chat box shortly. Great, thanks.
I wasn't ignoring you. 5, 4, 3, 2, 1, go. All right, everybody, we're back. Okay, so next section we're going to have a look at is the router tips and tricks. Okay, there's a couple of things just to chat through with you, just to show you what you can do with your router and what's capable in terms of your router. It's not limited to what I'm going to show you. These are just some thought-provoking little tips and tricks that I'll pass on to you, and then just to whet your appetite, you can think about maybe what you want to evolve in and develop and do. All right, just 1 minute. And that ad was brought to you by Keith. Right, okay, before we move on, have a look at this slide. Can anybody work out what's going on there? It's been up there long enough. You should have... Yeah, you're planing a piece of wood with a router. No? No? You've heard of the live edge? And those epoxy thingy jobs that they, whatever? Okay, so maybe the perception's a bit awkward, but there's a piece of board with the piece of timber, the slab, lying on the top of its live edge. But what's happened is that it's probably warped and bent and whatever. Now, in order to flatten that, you could put it through a thicknesser, but there's no thicknesser wide enough to do that. That could be well into a meter in width. So what they've done is, yeah, they've developed what is called a sled that you can then place your router on top of with a nice little brush to collect the vacuum up the dust and everything. And then you can move it across the top of the sled, and then you can move the sled down. So you put a nice big router bit on the bottom of it, nice big diameter, maybe a 50 millimeter, 60 millimeter. I wouldn't go more than that. Otherwise, its centrifugal force is extremely high on the outside, on the peripheral of the bit. So it has its own little issues that come into play. But then they would use that. So basically what they would do is start at the top and then move it across, and then go up and down, and then move down, go across, move down, go across, and then get it relatively flat. There's still a lot of sanding work and everything to be done after that, okay? So that's, I think this one is made by Woodpeckers. I think it's their model that's on there. But you could very well make your own. I've had a student that was here one Saturday, and he was making his. I showed me the plans. I said, yeah, it's doable. And about 5:30 that Saturday afternoon, he sent me a picture of the thing operational. So he set it up in about 4.5 hours. So proper working and everything. So if I need anything big done, I normally say to him, come on, I'll have a cup of coffee with you, pop past, and then go and do it. I don't have to set it up. Why not? That's how it works, okay? In fact, he was with me yesterday. We were busy sorting out a table. So, so there we go. Okay, that's what it is. So that just shows you some of the auxiliary stuff that you can put together with a router. Okay, so, all right, let's concentrate on what we're going to do here. These are the tips and tricks. I want you to look at this slide and then just orientate yourself, have a look and see what's going on. So we've got that's end grain, so it's a solid piece of wood. This is a top slab, whatever, maybe it might be a panel or something. I'm going to assume it's a top. The end grain, the grain's running this way. Side grain, side grain. Okay, before we start, when you're busy with your router, you need to move in one direction only. In the wrong direction, it can cause a bit of a headache for you. So how do we move around to do the routing work? So if I asked you, if you want to route the edge of this table, which direction would you go with this router? Dudley? In the right direction. Okay, right hand. Thumb is the edge of the board. Index finger is the direction you're going to go with the router. So let's hear the answer now for routing this table. Don't worry about that. Just Okay. But there's a hole on the inside of this table, and I want to route that. Which direction do I go? Doesn't matter. It's the same thing. Put it against the edge of that hole and just go that direction. So in this case, it happens to be clockwise on the inside and anti-clockwise. Forget about that. Just use that. Just use that. On the right hand. Don't come and tell me you're left-handed. On the right hand, okay? Just use that. Now look, some days it gets quite stressful in the shop. We've got to do a lot of things. And we're doing climb cuts and we're doing normal cuts. And then you get to a point where your brain is just a little bit wired. And then you have to think about, oh gosh, which direction am I supposed to go? It happens. Then it's simple. Okay, I've got it. Off you go. Do you understand? It happens. That's all you need to remember. Edge of the board, direction that you're going to move the router. Okay? Don't worry about any of the other hocus pocus jiggery. All right, so if you look at what the guy's doing here, he's got the router and he's now going around. In this case, it's a counterclockwise, but it follows the rule. Okay, does that help you? But before you start doing a solid piece of wood like this, there's one step, or in fact, it's two steps that you should do from the onset. Now, those of us that have used routers, and we've routed a square board, solid timber, so the orientation is the same there. Here's the end grain, side grain. So I go around with my router, and I'm coming down here, and as I exit out of here, it throws out a splinter on this edge. And then I stand and I look at this. And then I get profane. And then I look at this, and I think to myself, why? Now, good days, you'll be able to find the splinter that came off. Bad days, you'll have to get a piece of wood that matches and cut it at an angle, glue it back on, trim it off, and then you're going to have to route it again. And when you exit again, it chucks another piece of splinter off. And then you look at it, you say, you've got to be kidding me. Well, you know what? You're the kidder and the joker, not the router. So there's a technique called a climb cut or a back cut, okay? And that's exactly what's being described here. So in this diagram, the two exit points on the end grain, you need to do what we call a climb cut. So what is a climb cut? A climb cut is where I've got the following. So instead of now I'm moving forward and then exit and it creates a splinter, what I do is I actually come in and I ride on that corner and I actually pull it back slightly. It's called a climb cut. What happens in this case is the blades attempt to remove the material and it compresses the fibers so that when you do go forward, there's not enough meat to create a splinter to throw it off, but you can clean it up. What you need to understand is, now, this is quite ironic. The North Americans classify the climb cut as a dangerous maneuver or dangerous practice. So they don't advocate it. This is coming from the people who use a dado stack on a table saw. And the Europeans have banned the dado stack, but they will permit you to do a climb cut. So it's a bit of an irony in terms of how this all works out. So by and large, the climb cut is generally safe, okay? But you need to go white knuckle on it in case when you're pulling it, you will feel the router wants to throw off, okay? But just, it's not going to viciously throw it away from you. It wants to move off, and then you get a fright and panic and whatever, so you might do something, but you need to be aware of it. So when you're pulling it back, and it sometimes doesn't happen at all, you can pull it back and you won't feel any difference. But when you're doing something like a piece of oak that's got extremely, it's hardwood, and it's extremely hard on the end grain. I mean, the end grain is so hard that you can't get a Forstner bit in on the end grain. That's how hard it is. If you try and put a Forstner bit in there, it chatters. Your whole drilling press, even if you've got a drill press clamped down, everything moves. That's how hard that end grain is, okay? So when you're pulling a back cut on or climb cut on a piece of oak end grain, you'll feel it going like that, okay? But remain calm, and nobody says you have to do the whole length. All you're doing is, 25 millimeters is all you want to do. You just want to mitigate that end bit. Okay. So for those of you that are a little bit queasy or uneasy about that process, well, there's another solution for you. What you could do is you could put this on a table or hang it over a table and take a matching piece of offcut and just
make sure that it's clamped on the back there, and then you can move across so there is nothing to chip out. Do you understand? So that would work for you. If you're not, but give it a try. You'll be pleasantly surprised. It's not as bad as you thought it would be. On the bigger routers, it's calmer. On these little baby toys, you've got to stand there good and proper, and then just, it's not going to throw it like a rocket. It's just going to, you'll feel it, okay? And it'll unnerve you, but you get over it and get on with it. Now, the other reason why we do the climb cut, and this is a specific reason, you all know what this is. Plywood. Who's routed plywood? Nobody. Yes, there we go. Let me help you out. It doesn't matter where you do this. You may be running down here, and the way that the grain runs, it'll pick it up and it'll actually splinter out one of the plies. So on your round over, it actually creates a splinter, and that looks horrible. So in that case, you put it down and you do a back cut. And then when you finish the back cut, you then go forward, okay? And then it cleans up. So the back cut isn't 100% smooth, but when you go forward, then it cleans it up nicely for you. It makes everything nice, flat, and even, okay? Don't even have to put sandpaper on it. So when you're working with plywood, that's a really good use case for doing the climb cut, okay? But try it. I've not had a nasty on on plywood. It's actually quite straightforward on plywood. It's gentle. I've not experienced anything major. But the hardwoods, like the oak, and I did the oak this week, man, it kind of, and I used this one for the circle jig because I wanted to use the battery instead of having the cords. So I wanted to just grab the head and move the head around. And on the ends of it, I had to do the climb cut because otherwise it's going to splinter it out. So I had to do the climb cut. And when I did that, it kept on just jerking off all the time. So it's normal. And you kind of pick that up. But then all you do is just persist until you've done that 15 minutes. And then you go around again, okay, and you clean it up. The other thing is that when you do the climb cut, there's less chance for burnout because oak is very hard. You've got to have a very sharp bit and high speed to try and get through the oak. Otherwise, if you so much as just, it's burnt it. So you've really got to move quickly. So when you do that climb cut, because it's trying to move away from the oak, it's reducing the friction that gets generated, which means you've now made a smallish cut, so maybe a 90% cut. Then you can come through with a forward cut that way around, and it'll take the last 10% off you without any burnout on it, or burn marks on it, okay? Because there's nothing. When that wood caramelizes, it could be on the surface, or it could have gone quite deep in. And I tell you what, it's a nightmare to clean that up. And on oak, it's the worst. Oak, ash, and maple, you'll cry crocodile tears when it happens. You look at you just say, why me? And remember now, third last step, route, final a little bit of sanding, and then varnish, eh? Third step that you've nearly, and this means you're done. And then you mess it up on that third step. Sometimes you've got to go back to step 10 and get going again, okay? Does that make sense to you? All right. Doesn't make sense, then it's no sense, then it's known as nonsense. All right, good. So that's the climb cut. Okay, so you get the idea of what they're trying to illustrate to you there. It's something that you will, I did a 4 meter by 1.5 meter wide table, okay, I made out of solid Kia. And I'm traveling around the table, not thinking, I just want to, and it's my last exit. I'm nearly done with this table. I'm excited. I'm finished. Because after this, it's going to be the finish, and I'm done. And as I move over it, I suddenly realize I haven't done the climb cut. And as I go off, I don't know who was looking after me, but I'm watching this. It's like a slow motion movie, like a Matrix. Off I go like that. That splinter takes off, and it goes on. I got my eye on, I'm tracking it, and it lands on my table saw. And I got the route in my hand. I don't want to take my eye off it in case the shop gremlins take it. But I got the route, and I switched the route off, and I get that splinter. So I could glue it back on. And it was perfect. It was perfect. Otherwise, I would have had to cut that thing off and then put another piece on and wait another couple of hours for it to dry and then trim it and then oh, man. Eh? So something was on my side. So please bear it in mind, okay? All right. So there's a bit of a closer shot. So this is what's going to happen with the climb cut, okay? You'll see it's kind of fuzzy and whatever the case may be, it comes back. But there's no burning on this, okay? But at least now when you go forward, it's just that bit that's enough to clean it up for you, okay? Look, you can, if you say have to do an 8 millimeter depth, do a 3 and a 3 and the last one is 2. then climb back 3, and then the last 2 go forward, okay? If you feeling a little bit edgy about it. Don't do a climb cut on a 10 millimeter cut or something like that, because then you'll know your history as well. Yeah. Yeah, so in this case, because I know this profile is going to follow through to that side, I would normally start on the back here, and then I would steer it and then come round with the climb cut. To try and land it, you never quite get it accurately, okay? Because you can sometimes mess up the edge. So I normally just pull it round and then come down. But just a smidge. I don't want to go more than that, just to clean up the section. But it depends on the wood as well. But you know what? I'll also be honest. Sometimes I just climb cut the whole thing all the way down. If the wood is soft enough to allow it, then I'll climb cut all the way to the back, and then I'll go forward and clean it up properly, because then you get a nice clean cut on it. You don't get any sniping, because end grain's horrible with whatever you do. You know, whether it be a miter saw, table saw, router, jigsaw, end grain always messes itself up. You've got to spend ages sanding that up, okay? Or planing it for that matter. And it's hard stuff, eh? So you want... Yeah. A tear out. Yeah, you could do that. Not going to work as effectively. Okay, because the masking tape will try and act as a clamp around it for you, but not as effectively. If it wants to create that splinter, it will do it. Eh? And then when you take your masking tape off, you take the splinter off with it. So no. If you want to avoid doing that altogether, as I say, just put a piece of scrap on the end of it. So normally when you do a project, don't throw your scrap pieces away. Eh? Always for your project, take your scrap stuff and throw it in a corner. I'm telling you, at some point you're going to need it. So either for the depth for your biscuits, grooves, finishing, when you're doing finishing, maybe you need to put a little bit of color in it. You want to test it, keep your scraps. Biscuits, if you're putting biscuits in to get the correct depth, you don't want to test on your real piece. You want to do it on that offcut. And then for things like that, so miter saws, when you've got pieces that you want to cut through, you want to put it down on the miter saw and then cut through, then you don't have any splinters coming out on that back part, okay? But it'll go cut through that, and then just remember you've got to move your scrap up a little bit and then take the next cut. You get the idea. Just so you've got something to buff up against, okay, to do a clean job. Otherwise, you get that splintering. It's inevitable. It's going to happen. You just want to mitigate that. The other way to do it, that's if you can work accurately, is to take your marking knife, if you've got a nice sharp blade on it, is to mark it and make sure you can cut on that line. Then you're not going to have those splinters. I did that this week. I'm just trying to remember on what it was. Yeah, it was on that oak slab, because I took the jigsaw and I was cutting it as close as I could to the edge, because all I wanted to do is use the upcut bit to go around it to clean it off in one run. I didn't want to go plunge, 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 because then you're just increasing your risk. So what I did was I just used my knife to cut the line just outside the circle line, just made a mark, and then I've used my jigsaw to follow that so it wouldn't create splinters as I was going down. So that becomes quite handy for you. Yeah. All woods, all woods. You'll know about it when you get them in your hand. Not one wood has said to me, I won't splinter you, I won't stick you. But man, they all do. Eh? So be careful, okay? Gosh, I watch people. Oh, sorry, just say that again. There's some noise coming from the back there. Yeah, the question is if you should do the cross grain first, and then it'll mitigate or reduces the likelihood of splintering coming into play, okay? But you know what, follow the rules or the guides that we've given you, and you know what, try it out. Pine's a relatively inexpensive material. If you've got a couple of pieces of pine, offcuts or whatever, practice on it and prove the theory right or wrong. You must test it, okay? And that's how you're going to evolve in your game. Test these things out and you become confident of what you're doing, okay? But I hope that makes sense now to you, okay? All right, don't do the whole table like that. Just do what you need to. There are days for you'll work it out as you get used to it, okay? All right, so here's a very good tip, and please, I hope it's one that you will follow through. Sand your wood properly. So sand the top, sand the edges properly, and everything's nice and clean before you start your routing process, okay? Because anything that creates a little divot or a little bump or whatever, the bearing will pick it up and it'll telegraph it into your edge. So when you look straight down, you're You're going to see it go like that. I mean, we do these things. When a guy says, oh, I just made this table, we stand over here and he thinks we're looking at what's going on the side to see how well it's made. You know, we pick these things up. So you want to get that all sorted out before you do your routing. The little bit of sanding you might do, it might be the bearing mark that gets left on the side because you were tense and nervous. So you've pushed too hard into the side of the wood and it's now made a little bearing mark. Or on the cheaper routers, there's a little bit of play in the plunge. You might have got a little bit nervous and you plunged a little bit too hard and it's now left a little line on the edge. You're going to have to get some sandpaper and just lick it to get those marks out, okay? Why are we so adamant about the sanding part? Because when you put your finish on, your finish will tell you how well you've done your job. It shows absolutely everything. I mean, my eyes are deteriorating, but I've got little things that I put on my glasses, and I've got my lamp, and I've got my little Rotex, and I'm sitting there and I lean over it. I know I'm in for about a 4-hour session on a tabletop, and I lean over it and I watch this, and as I'm going down, I'm watching this, and I follow the rules. I move slowly. I don't go quickly across it. I move slowly, and then when I've done a section, I lift it up and I take the blow and I blow everything off and I dust it off with a brush and I put it down and I go again. That's a top. There's nothing worse than finishing it off and all these little pigtails, the little swirly marks, suddenly just pop up like magic before your eyes, and you look at this and you say, you've got to be kidding me. Now you've got to wait for your varnish to dry off, and then you've got to scrape it off, and then you've got to sand again. Do you understand? And if you have to sand again, that means your little edges have gone out now. So it means you have to reroute those edges again, and then you're going to go and start all over again. Does that make sense to you, or doesn't it? Yeah, well, you'll work this out, okay? I hope it makes some sense. So please, watch out for that tip. It's extremely important. And sometimes, you know what, you clean forget that. I just don't. Because I know the value in that. I don't have time to go and refinish a table again. I just don't have the time. Got to get things done. So mistakes like that are costly, okay? In that case, it makes a lot of sense, eh? With a couple of rand attached to it, yeah. All right, so edge routing, narrow stock. Okay, so just a small little, just a couple of things for you to kind of understand, okay? Have a look at this. So you've got narrow stock that you need to put a little round over on, or you want to put a Roman ogee or something on it. So what they suggest you do is, and this is why your workbench is called a workbench. It's not a piece of furniture. You know, I've gone into shops and I've seen the guy's workbench is pristine. It looks better than his coffee table. And I'm thinking to myself, how much work have you done on this thing? Oh, no, I placed this rubber mat out there and whatever. Gosh, man, you saw my top. That top's only about 18 months old, eh? I mean, I've got to throw it. I mean, it's got cuts in it. It's got holes that are drilled into it. And when I'm busy mixing and epoxying, I've got anything left over, I fill the holes up again and then sand it down. But I mean, it gets used. So please, take that piece of, so what you do is, there's your piece of wood that you want to work on. So what you do is you get a piece of wood, hopefully with the same thickness. You put that down at a certain, you might want this a little bit overlapping, I don't know. But put this down and then screw it straight into your worktop, one on this side, one on that side. And then you can route through. What you could do is you could also have a piece that's the same thickness as that and put it across the top here. So it acts as a stopper to stop this from moving forward. And then also when you exit, that there's no tear out or anything of that sort or that nature. In this case, there shouldn't be, but you might have end grain in that particular scenario. So you set it up accordingly. And then you can go in and do your routing. So while you're busy routing, so here's your strip, there's the little block that you've got. Your router will bump it up against the side, and then you're going to move it down, okay, and then do your routing, okay? So that's a simple little thing, but it's valuable because it's things that you need to work with all the time. All right. Right, so cutting dados using a jig. Now, let me explain this to you. So let's just give you a background. We call it a groove, okay? The Americans call it a dado. And the only reason why we keep the word dado in place is because just about every book or social media video that you look at or whatever, they talk about a dado, okay? And then the European guys get a little bit iffy about it, and then they do their presentations, and then they call it a groove. And then the Americans say, what's a groove? You know, you get your groove, my mate. And, you know, that kind of just doesn't work. But anyway, so that's what it is. It's a panel. Listen to what I'm going to describe. 2 panels. You want to build a bookshelf. 2 panels, and you're going to make grooves to recess the boards the shelf boards into those grooves, okay? So in other words, those boards are fixed. You can't move them, okay? Now, we're in the modern age now, so we get ourselves a shelf pin jig, and we pop holes, and we put shelf pins in, and then we drop the shelves on top of that. Is that right? And then in a couple of months' time, the shelves sag, and they fall out of the pins, or the pins crack, and they fall out, or, yeah, there's drama all the way. But if you did the job properly, like, because that's what proper woodworkers do, is you make a groove, you glue it in, and it's permanently in that position. So you can't move things around, okay? Well, make the shelf and make sure everything's made to fit. That's really what it boils down to, okay? There are different systems that you can work with, but you know what? We live in a modern age, so we do things the modern way. I don't like the shelf pin style, but if I have to use it, then I'm just going to describe a quick technique to you. If I have to use the shelf pin, now you'll know this, everybody knows this, that shelf slides in and out, it moves, it becomes rickety, a little bit of more humidity in the air, and it might bend or warp or whatever, if there's water or whatever. So normally what I do is I just route a little groove where the two shelf pins go in on my shelf. So when I put my shelf in, I put it down, and then I just slide it forward, and it drops into those two little pins. So I only go, on a 16mm board, I'll make about a 5 to 7mm deep, and a groove probably about 10 millimeters in. Just make two little grooves so that it locks in on those pins. So you don't buy the pin with the plastic bit on it. You buy a clear pin. In other words, you've broke all the plastic off, you'd be left with the pin itself with a little shoulder. Then it can only go so far in, and that little pin sticks out. And then I ride my board and I drop it straight onto that. Do you understand? So there's no movement whatsoever that's going to ever happen there, okay? And that just locks it in, and it's great. You want to adjust it, then you lift it up, pull it out, adjust your pins, slide it back onto the top until it locks in. Do you know it'll lock in, sits flat, and then you carry on again, okay? So you can take it up to that. But this is something now that we're going to discuss. So if you are going to go this route, and I would urge you to do that, if you are going to make proper shelving or cabinets or whatever the case may be, you don't have to go mad and do every shelf like this. You may want to do bottom, middle, and top, okay? And then make the movable shelves in between. But then at least what you do is you recess the shelf into the side. So on your shelf, you've got these little grooves, and your board is cut just a little bit longer to slide in on that, okay, into that groove or dado. So typically you would make a little jig, and it would be the first jig that you would set up. So you make a little T-square type jig, which is very handy in the shop. T-squares are always handy. So if you set the T-square up properly, then you can make this quite easily. So there's the back of the T, and that's the long part of the T. Make sure that it's perfectly 90 degrees in those two corners, and you've got yourself a nice T-square. And that T-square works for you because maybe you want to mark a big wide sheet of board or whatever, then you can put your square up against it, mark it all the way to the other side, and then make your cuts. Okay, so that will become probably one of the most used little jigs that you'll ever make in the shop. Okay, so that's step one, is you would create your straight edge. Okay, so there they're just showing to you, you take your piece of board, you then clamp it down, and then screw the screws in it, and then you can clamp both ends, or one end is sufficient in this case. Then what happens is you take your router. Now the router base has a certain distance from the edge. So from the center of where the bit comes out to that edge, you will then calculate where you want to position this. So you bump it up this part against the edge there, put your bit in that you want to make the dado with, and then you start at the back and then you move it through. And then what it does is it creates a little groove in your T. What that now means is wherever you want the groove on your board, you line it up with that little groove that you made with your T. So now you know when you bump it up against that edge and you route, the router is going to go through your original groove, and then on your pencil mark, it will follow through and then do the groove for you. Does that make sense to you? So you use the tool as it's designed for to assist you to jig it up and send it through. I might have something a little bit closer. Let's have a look. All right, okay, so not very clear, but there's definitely, you can see there's the T with the original groove. There's a little pencil mark where the bottom, so you must decide, top or bottom you're going to use as your guide. Just mark accordingly. But in this case, they've used, if this is looking that way, we'll call that the bottom. So there's a pencil mark. Run your router through and then make your groove. Watch out, your router's moving in the right direction again, correct? Can you see that? All right, so it's not coming back at you, it's going away from you. And there you can see the other dados or the other grooves that have been made further down, okay? And the nice thing is that once you've marked both boards, it's just a case of putting that T-square down with its groove and then off and line it up with your mark, and then you can make your groove, okay? And I would urge you to start looking at making things like that, because that's what makes you a proper woodworker, as opposed to the others where they use melamine and then they hammer nails into it or screws, and then they say, oh, look what I made, okay? I mean, oh, look what we made, yeah, that kind of thing. So kind of bear that in mind, okay? All right. Okay, so another tip for you. If you are using or want to make grooves or dados, then take a bit that's the same thickness as the board. So luckily, we're one of the few countries in the world that use a 16 millimeter thick board, okay? So if you wanted to make a groove to put the 16 millimeter board into it, about 2 or 3 years ago, they finally made a 16 millimeter diameter bit. Then you make your groove with a 16 millimeter diameter bit, and you can put your board into that, okay? And then it's nice and secure and tucked away, okay? If you're doing it out of plywood, which most people would do, then do it with your plywood, and you can put glue in it, and it'll glue it up. I mean, and it's as strong as anything. And then you can get fancy, go and get laminates, and you can put laminates on it. And there's some amazing laminates out there. I use laminates quite a bit in the work that I do for clients. I mean, they've got some amazing stuff. Laminates is compressed paper. And they've got designs that look like, it looks like granite. They've got designs that look like wood textures and stuff like that. There's amazing stuff out there, and they're not expensive on it. You know, the sheets, you get about a 3-meter sheet by about a 1.2, 1.5 meter wide. And the costing can be anything from 350 Rand up to, depending what you want, up to 2,000 Rand. You get metallic sheets and stuff like that. So there's a lot of stuff that you can do on it. All the new colors that you can think of. So have a look at laminates. I think everybody, especially in this country, we think of laminates like our mom's kitchen, you know, had that laminate on the top. The laminates are a different game altogether today. They really are. So there on those countertops, those are basically like a laminate that's on top there. Okay, except that one's a molded laminate. If you put enough heat on it, you can bend it to do what that is. And they're fairly straightforward to put on as well. It's adhesive on both sides. Put sticks in, and then as you pull the stick out, it drops and matches the contact adhesive, and get a roller and roll it on. Pull the other stick down, and as you pull the sticks out, you can just keep on flattening it. They look amazing, okay? So something worth looking at, all right? Not trying to sell it, but give you an idea to go and look at it, okay? All right, okay, so there we go. That's what that tip is. Get the same diameter bit that matches the thickness of your board, okay? So then it's one cut. If it happens to be a wider groove that you need to make, you don't have the bit for it, please remember to start on the left-hand side and then move over to the right, because we still want to keep that direction in place. Do you understand? So if you started up against that side and then moved over to do the balance on this side, remember you're now doing a climb cut, eh? So please be careful of what you're working with, okay? Be careful of these things, okay? So just manage it. All right, now this topic again, the word that we use is rebate, and they call it a rabat. Now it's the French word, okay? And depending on who landed where, the Europeans continued saying rebate, it deprecated into rebate, and the Americans carried on with rabbit, okay? So it's a rabbit. So what is this now? So if you've made your bookshelf, and I'm going to look at the back of the bookshelf, so there's the two sides of the bookshelf. You've done your grooves or your dados. Then you want to put a backboard on. So let me ask this question. How would you mount a backboard onto the back of that shelf? I'm going to ask you this. How would you do that? Okay, that's one option. Any other options? Yeah, cut it to size and then just screw it in, okay? Or nail it in, okay? And if it happens to be chipboard, you can't screw in on the edge. And if it happens to be plywood, you can't screw in on the edge. And if it happens to be MDF, you can't screw in on the edge because it's just going to burst open. So none of those three options is a solution for you. If it's solid wood, yeah, you can do it. But now it's going to cost you up your game just because you want to put a backboard on with a bunch of screws, okay? Or you want to nail it. Then you nail it and then you don't aim properly and then it blows out on the sides and whatever, okay? Not so much on the chipboard and the MDF, but more so on the plywood it can happen, okay? So what the proper way to, and then of course the disadvantages is that over time that board comes loose at the back. Is that right? We forgot to mention the staple gun, eh? Okay, so over time that board comes loose and now you're trying to fix that board up. I mean, come on, it's an absolute nightmare. And seriously, when I look at the way these guys build it, I know why. It's all to do with making money. You know, it's easier just to get that masonite board with a white face, drop it on, mark the shape out quickly, cut it out with a jigsaw, clean it up with a bit of sandpaper, nail it down, stick it up, because it looks like on the inside. What's going on at the back, they'll never see, or we hope. Okay. Okay, so there's two proper ways to do this. If you're a proper woodworker, one of the ways is you would cut a groove all the way around on your boards. That's the 3.2 millimeter thick. Your table saw blade is 3.2 millimeter thick. So if you set it up properly and you cut all your boards on the inside with the groove, then you can cut the board and slide the board in and drop it, and you can close the top off and leave a little bit of a gap so you can pull the board out if you ever need to replace it. Okay, that's the one, which is the one that I would prefer to go for. The second option is you create the rebate. So the rebate means you take a piece of wood and then on the edge, you cut a little groove into the side. Yes, so a little groove on that edge that will allow you to drop the board into that, to recess it, to drop the board into that. And then you can toe in the nails in from the side, okay? But then again, the risk of blowout. So not a very popular thing. I don't see much in terms of rebates anymore on cabinet making, okay? If anything that I do see, and I do it myself, is I'll cut the slots and drop the board in there. Because if should anything happen, you can always take that board, remove the top of the cabinet, and then my cross member at the top of the cabinet is just pulled back, then the grooves are just behind there. Then I can drop it in, I can put my top back on it. Then nothing's going to go anywhere. When I take the top off, then all I have to do is slide that old piece out and put a new piece back in there and put the top back on, give it a good clean underneath, and then put the top back on, and it's good to go again. Does that make sense to you? So that's what the majority of us would be doing. So the rebate, I'm just showing it to you because it is out there and you may need it for a reason. This is how you would do it. The other thing is there's a number of bearings that come into play. And you're probably thinking, but why all these different bearings? Isn't it just a standard process? Well, you get different widths of thicknesses, okay, or different thicknesses. That means you would have different rebate sizes. So generally we work, in carpentry, we work on thirds. So if it's 16 millimeter thick, then we're going to look at 4 millimeter in. Do you understand? If it's 20 millimeter thick, we're going to look at about a 6 or a 7 millimeter in. These bearings will allow how far the rebate should go in. So when you set that up, maybe this one is set for a fairly big rebate. This could be a 12 millimeter rebate because the board thickness is 1 inch. Let's assume. So in this case, all you need to do is just change the bearing out. If you wanted a 4 millimeter rebate, you would put a bearing that's suitable for 4 millimeters that it can run against. Do you understand? That saves you the cost from having to buy different bearing bits all the time. Because a bearing bit itself could cost you about 300 to 400 Rand for one. Now, if you need it for all the different thicknesses that you've got, it's going to cost you a couple of thousand Rand. Where in this case, this whole kit would probably cost you about 1,200 Rand. A job done and it's covered. But now you're thinking, well, that cost has been made on there and I'm only using it for that. But hold on, I'm going to show you a little bit later where the bearings become useful to you again. So you have a bearing kit and you have different router bits for those bearing kits to manage different widths and thicknesses and so on, if that makes sense, okay? All right, does this make sense to you guys? Okay. All right, so there they go. They're showing you the rebate on the edge over here. So the guys are busy doing the rebate. And that's where the back panel, so the shelves would all come in down like that. And the back panel would then come up at the back. It's a lovely way to make a cabinet. It really is. But it has its caveats, okay? And if you use a nail gun, which is the only thing you can use to really fasten it down, man, if you're using solid wood, just pray it doesn't come out on the side you want it to come out on, okay? And it does. It follows the grain and it pops out on that back. And it just, you'll sit down and just cry. Put your hands, up and that's it. I'm giving up. So generally speaking, that's now really old-fashioned. So if you do see a cupboard that's got that, that's pro work, eh? But that's coming out from 20, 30, 40 years ago and even earlier, okay? So that's what you want to do with there, okay? So I hope that makes it. By the way, can you see they're using the router with a fixed base here on this? They're not using the plunge base because it's a bigger platform. So the center of gravity, while sitting in the middle, they can pull it over and hold it on the side. This handle's quite convenient, but if you've got the knobs on both sides, the fixed base makes it easier to work with, okay? So now you can start seeing where it comes into play. All right, so router bits. Let's have a comment about the router bits. I think we always get caught out with the different router bits. So what I want to do is I'm going to show you, I'm going to give you 2 router bits. I'm going to hand it around while I'm busy talking. And then you have a look at it and you tell me which one is the better quality of the two, okay? All right, so router bits, they come in a number of variations of different types of steels or metals. But the two common ones are carbide tipped and high-speed steel. The question to ask is, which one should you look at, okay? I would always advise that you go and purchase a carbon steel as opposed to a high-speed steel, okay? The high-speed steel is good, does the job, but it does blunt very quickly, especially when you're on the harder wood. So sometimes you may find out on a table, you'll probably get about 3/4 through and then suddenly see it starts burning and it starts chattering. Then you know that your bit's done and you've got to put a new bit back on there to carry on with the rest of the job. It's that long. So in other words, you're talking about maybe 10 meters this thing will last and then it's dead. Because that's the distance of routing as you can do. And then it's, say again? Yeah, exactly. And there you sit. And then you've got to take out your hand tools to do the roundovers, okay? So you want to avoid them. But they're cheap, they're nasty. So the one I'm handing the one, I don't want to talk about it yet until everybody's had a look. You want to make sure you take the high speed, no, not the high speed, but the carbon steel. The carbon steel, you can work well with them. They manage and tolerate heat quite nicely. They can be cleaned and reused, obviously. And then if there is a little bit of a nick on it, you can get a little diamond card and you can just give it a bit of a polish on the flat face, not the curved face, the flat side. Just lick it with your little diamond card and it's good to go. Okay, so they're pretty good in that regard. And like I said, the high-speed steel, for the price you pay for them, it's not worth the effort to even do anything, just in the box, okay? I'm just waiting for that to go around, then I'll tell you the story. Now, in this country, unfortunately, we've only got one supplier of router bits, okay? One supplier. I know that Freud are now entering the market with their bits. Freud are owned by Bosch. So all Bosch's router bits are high quality, made by Freud. Freud have got an excellent product. And then Freud also manufacture for a couple of other countries like Trend or companies and stuff like that. So they manufacture for them, which are very good brands. And they just rebrand it. They'll just change the colors or whatever the case may be. So in South Africa, what we get there's one brand that comes in, and that's the Protect brand, okay? Then it gets repackaged for Talkcraft. It's the same brand product. We get what we get. So that would be the carbon tipped one, okay? So it's a relatively good quality for the most part. The bearings are something to be considered. And I'm going to make these comments because they'll fail on you. And you always need to, when you're working with a bearing bit like you saw there, and they've got little collets on them, please make sure that the little collets or the grub screws are tight before you start your job. You don't want to do that final bit and then that screw falls out or the collet goes loose and the bearing starts moving. And then suddenly you're now traveling into the side of your piece and it's a mess, okay? So you need to make, that's why I say, after you've worked with these things, you need to make sure that everything is functional and working properly and sharp, and anything that's not working properly, throw it or whatever the case may be. All right, so I'm sent around 2 bits and you've had a look at them. So which one do you think is which? Okay, the guys that have worked, that have worked with router bits, can I just ask you to hold back? The guys that haven't worked with it, which one did you think was the quality one? This one. And this one? Anybody thinks this was the quality one? So, I'm going to punt my mate at Main Hardware. So Jeff Sadisky, it's a mate of mine. He owns Main Hardware in Joburg. Gets hold of us and he says to us, I've got a container load full of router bits. Do you guys want to come and get the bits? How much? He says, you know what, do me a favor, take them for $10 a piece. I think, well, this is a deal. So we get out there and we grab the stuff. So I let Hardware Center know and I let some other guys know. So we all go down and we go get the bits out and we have a look at this. Now we realize what the problem was. The reason why he was getting rid of the stuff, he brought it in at a very good price. And the reason why he was throwing it away at about 10 Rand a bit is because in the first instance, they were high-speed steel. Okay? And in the second instance, not one of them had a label on the box. So to get someone to try and work out what the size was for each one was going to just be an expensive exercise. So he said, normally we know what these are. I mean, that's a 6 millimeter and this is a 4 millimeter. So we know what they are because you use them all the time. It's the guys like yourselves that aren't familiar with this. You don't know what the heck it is. So he's got to put a size on there. So he says, just grab the stuff. Do me a favor, grab and go. So I did. I must have spent about 1,000 Rand. So that's 100 bits. So I use this stuff. Man, the bearings fall apart. The screws just fall out. The stuff chips like nothing. But you know what? When it's finished and it's knackered, it goes straight to file 13. That's the high-speed steel. Okay. Looks nice though, hey? Packaging was awesome. This is actually the better bit. This one. And this is the Protect bits. Okay. All the ones that come from Torcraft. That's all we get here. Okay. The Freud one would be red. Okay. And it'll say Freud on it. And any other bits, I mean, the guys will tell you, oh, white side is the best bit that you can purchase from the United States. I'm cool with that. I don't know nothing about white side. I know about the bits that I use, and they work properly for me, and I'm happy with them. I'm not going to go and import a bit for 1,800 Rand, and it's going to do the same thing that a 900 Rand bit's going to do. Okay, some bits on their catalog are very expensive. The more fancier the bits get, but then you can get the same thing from the UK and bring it in on, bring it in from the UK at a lesser cost for a bit that you know was made by Freud. Okay, rather than buying it from Freud. Yeah, so a little bit of shopping and discerning. Being discerning about what you're using and what you're working with, it's going to save the day. Okay, does that all make sense to you? Let's go for round number 2. So you always, when you start your routing adventure, sales guy always wants to sell you a box of bits. Eh? Who's all got a box of bits? Come on. There you go. Yeah. Anybody else? Okay, this is important. I'm going to save you money, and then you owe me a chocolate. Out of your box of bits, it's about, let's just guess, I think it's about 12 bits in that box, eh? About. Oh, you got the big one. Yeah, and there's even a bigger one with like 36. Okay, so yeah, you went big on this one. And how many you got? You got the small box. The big one. Oh, you guys spoil yourselves, ain't you? Dudley? The small one. All right. So out of your kits, yeah, how many bits have you actually used in that box? So it's the straight bit, one of the straight bits. There's a straight bit with a bearing at the bottom. Yeah, you've used that. Maybe. You've used the cove bit because you wanted to try that out. You want to see how that works. And you've used maybe the 45, maybe. Hey? Oh, the Roman oak. Of course, you all try that one. You just want to see what it looks like. So you've tried, at max, you've tried 4 of those bits. And the other 12 or 24 or 36 that remain in that box have cost you money, eh? Right, so now that you know with a bit of wisdom, you buy the router bit you need, not the one you want. Okay, I hope that makes sense. Seriously, I've got the kits, but they were given to me very politely by a lot of people. So I've got 3 kits of one and one of the small one, and then I've got the big one. So you really just, I know this because I look at those bits and I always have a good chuckle. I say, my word, I've never, oh, look at this one, it's brand new. I've never used it. But the other boxes, I mean, the most common one for me is this one, the roundover. Gosh, the roundovers I go through like nobody's business. So those freebies in the box really did me a good justice there. So get the ones that you need, okay? So not the ones that you want, okay? So that's really how it works out. So moving forward, if you haven't entered the game yet, you're saved, okay? So just get the stuff that you want, that you need, okay? Does that make sense to you? But you know what? At some point, do have a look at the other bits that you've got and try and see what use you can get out of them. What would it work? What would it do for you? Because some of them can be used quite fancy. And then another thing you need to also learn is that router bits, to get profiles, maybe using a combination of bits can give you a profile. So in your kit that you've got with the OG, the Roman OG, and the roundover, some guy worked out there was something like 17 profiles that you could get out of that by using combinations. That means using one at a certain depth and then part of an OG and then a part of another, the Roman OG would give you different patterns that are basically standard patterns for cornices and dado rails and stuff like that. So you need to just think carefully and then start. So that's another thing to think about, is mixing your bits in between to try and get the different effects that you want to play around. Practice on scrap first and then make a note of what you used on there and what sequence you put them in. And then you go and make the stuff and then you set it up. Always nice to see a fancy little edging. You say, wow, always say, I wonder how the guy did that. And I look at it carefully and say, oh, okay, so halfway is the OG, part of the OG. The bottom part is a cove. And then the top part, he's used the, hey, that's neat. So you use 3 bits and he's got a beautiful looking profile. Okay, does that make sense?
It is important to know which order you must use those.
Yeah, sometimes it does, because you need to use maybe one to the bottom first and then build up, or from the top down, or maybe from the middle and then up and then down. So just depends on what pattern. So you got to play around with it. But that's a nice little adventure that you can go and embark upon. Okay, so let's have a look at. Are we okay with the router bits now? So the router bits, I think you're now clear. You can get these. You can get them cheap, like we did. Use them, and then when they knackered, you throw them. Okay, and then these guys, look after them. They're expensive. Okay. Yeah. Yeah, that'll be carbide. Yeah, carbide tipped. Okay, and then you can clean them. So this one you can see they're a little bit tight. You know, if the paint starts peeling off these things or burning off, you're doing something wrong. You're either too high speed or too low speed or hardwood or whatever the case may be. So you need to make sure the paint doesn't peel these things, okay, or burn off. If stuff starts burning off, then you know you're going a little bit crazy on that, okay? The rule of thumb is the thinner the bit, the higher the speed. The wider the bit or diameter of the bit, bigger the diameter of the bit, the slower the speed, eh? All right, that's why we've got a variable speed on our machine. And then also the wood. So there's a lot of factors. So please practice on scrap before you start hitting your project. Okay, let's have a look at the depth of cut, okay? All right, so if you have a look at this, you'll see there was a pass that was made, and when they were, this is oak. And as they were working on this, you can see it started caramelizing or burning the wood, okay? But you don't go, so in other words, if you had to go 9 millimeters deep, you're not going to go 3, 3, and 3. I would go 3, 3, 2, and then 1, okay, to do the last cut. So that'll give you, so you can see over here, there it's made of the burn, but then what happens is just the final pass, a nice shallow, just to finish off the final pass, does a nice clean cut for you with no burning or whatever. If you've not burnt wood yet, then you won't know what it's going to, how much time it takes you to get that out, okay? Who's done that? You guys have burnt wood. You've burnt wood. And on oak, it takes forever, hey? And then you look at it and you say, oh, and you know what we resort, I've had a case where it burned so badly on ash, I was actually getting quite irritated with it, that I recut the edge of the table. That's how it just kept on burning. And then I did it again, but this time just plunged. I was in a hurry to get finished, and I just said, okay, stop it. I phoned the client up. I said, I'm going to be about an hour late. Just bear with me. They said, no, it's fine. It's okay. I'm only going to be home at 5. And I'm thinking, oh, gosh, and that means I've got another 4 hours. Okay, so then I calmed down. I recut the edge. That's how bad it was burnt. Recut that edge. And then I said, okay, now let's do it properly. So I went 3 and 3 and to do whatever I needed to do. And then it was beautiful. Why did I not do that in the first instance? Eh? In a rush, and I wanted to get done. But you learn. And that stuff doesn't clean up, because once you start sanding those profiles, you start taking the little square edges off. You start messing up the little coves like that, and it just becomes, so that starts getting a little bit of a round over. That gets a bit of a round over. This gets knackered. It's not worth it, man. Remember what we saw about that little router, the first electric router? You shouldn't have to sand. Is that right? Okay. Where are you going to get caught out? You're going to get caught out when you're doing round corners. You're going to get caught out. So when you do a round corner, when I'm talking about when you've made a radius on the corner, take a piece of scrap and work out what you need to do. And don't do the whole thing in one shot. Do a little bit, move it off, and see where it's burning. If it's burning, that means look at it and say, okay, I need to slow down a bit. Then you slow down, and then it's too slow, and then it starts burning again. Then you've got to try and find the sweet spot. So once you finish that, then you drop it a little bit more, and then you come around. Now you've got it right. Don't guarantee it for your final project, because your project happened to have a little knot on it that your little test piece didn't have. And as you go around, it hits that knot, so friction builds up, and you've got a burn mark on the edge of it. Then you look at it and you say, come on, man. What did I do to people today? Nothing. I was by myself. You get the idea? Okay. All right, depth of cut. There we go. So basically, what do? So it's 3 millimeter, 3 millimeter, 3 millimeter. Okay. Now your router does this for you conveniently. So let me show this to you just while we're talking. So on this Bosch, it's got this little stop or height stop or turret. It's this one over here. This one is the best one. It's a 21 millimeter depth. You can go from 0 to 21 millimeter depth. It's got, I think it's seven stops that you can work with, and each one is 3 millimeters between it. Okay, so this is a first prize on this machine. It's absolutely impressive. The other machines will have them. So In other words, you'll see here on this little Handheld portable, it's got the same thing. These are 4mm as a matter of fact. It's only got 3 little turrets at 4mm, so it's 4, 8, 12 if you set it up properly. So this one works. You can also use the grubs, loosen the grub screws to change the depth between each one. Maybe you want to change it to 333 rather than 444. And then the other ones will have it, more or less, in various configurations. But the router that has the best configuration is this. I'm just so impressed with this. It's amazing for 21mm depth. I mean, this is the toy that we'll hit when we've got to do really deep stuff. I've got to go to 16mm or something. This is the one I'm going to use, okay? Because now I don't have to worry about, setting. So at one stage, I used to go between 2 routers to get my depth. So 2 routers with the same bit. The one would do the first 3 steps of depth, and then the other would do the other 3 steps of depth. Do you understand? Now, this one can do the whole lot in one shot for me. So it really makes a big difference in terms of what you're working with, okay? But you're all sitting here looking and saying, oh, that's awesome. Thanks for telling us. But how do you do that? Okay, I'll show that to you when we finish the presentation, okay? All right, so that's how it would work, okay? So those little turrets will be the depth that you're going to do the cuts, okay, to make it easy for yourself. Okay, so now, some other uses of for your router. And in this case, this is a Biscuit jointer. Who's got a Biscuit jointer? Anybody got one? They're amazing little toys, okay? I mean, I used mine last night to joint that tabletop. Magic, eh? You get so clued up and so used to how it works. I mean, even got a little configuration jig to hit it mid-board. I designed a little jig so it actually fits in, clamp it up, and I can hit mid-board with a piece of board against the edge, and I can pop these things out quickly. Magic little thing. So what is this Biscuit? Well, the Biscuit is a little wooden oval, like a rugby ball, okay? They come in 3 different sizes, 0, 10, and 20. So 0 being the smallest and 20 being the biggest. That's what we use. And there are other sizes and configurations, but those are the 3 common ones that we work with. And then it's about 4mm thick, about 3.2 to 4mm thick. It's made out of compressed wood with the grain that runs at 45 degrees to your edge grain, okay? On long grain, by the way. So what you would use for those is you can use them in cabinet building. So they will work on anything that remains pretty stationary. So if you're doing kitchen cabinets and stuff like that, you can use Biscuits. And then typically for uprights and stuff like that, they're beautiful. Gosh, you put them in, put the uprights in, drop them down, and then put the Biscuits at the top and then lock your top down. Sometimes on the uprights, you don't even glue them in. They're just there to keep things in place because nothing moves and fiddles around. Yeah. For the Biscuit cutter. Yes, 1/4 inch, 1/2 inch, you'll get them, yeah. So I'm going to show you what the cutter looks like. So what's happening in this case is this could be a lamination process where the guy is cutting a groove to laminate 2 pieces together. And the reason why they do that is to keep the boards flat. Because, you know what, when I laminate, if the board is about 1 meter long, I don't need to put anything in between. I just put the glue and put the 2 edges together, and I'm good to go. And now you're going to turn around and say to me, oh, but is that strong enough? Go and try it and let me know, okay? That's how we work with it. The only reason we're going to put something in between between those joints is when it starts getting a bit long and the boards are cupped or bowed, okay? And we need to keep things straight. It's invariable and inevitable this is going to happen. Then we put something in there. So the something that I use is Biscuits because the machine's quick and it's accurate and it's got a little bit of play in it. So if it's a little bit offset after when I'm busy with the glue up or whatever, I've got some little room to play with it. Because when it makes the slot a little bit wider than the Biscuit itself. So there's a bit of slop in it that it can play around with. So you're not fixed to that size, okay? So you don't have to work 100%. You need to work reasonably accurately, but not 100%. So if you're 1 millimeter off the line, not going to kill anybody, okay? But in this case, when you have on the table like this, and you use it with a slot cutter, then obviously you can make little grooves all along, but then you need to mark where you make your grooves because you're going to have a matching one on the opposite side. But in this case, you just make one long groove, and then you just pop your Biscuits in, which is great because now you pop your Biscuits in, and then the opposite board, you don't have to line anything up. You just make the groove, and you just push the 2 parts together. Where that becomes particularly nice is when you've got a 3-meter table that you're busy building. Most of the boards are flat, and there might be 3 boards over the 800 or 850 width. 3 boards are bowing and cupping. Then you want to pin them down. So that means 2 boards on that end are lifting up. So you want to flatten those 2 down there, and then you want to get them straight in the middle. Now what happens is if you position them all evenly with a machine, Then what happens, you get a little spot where it needs a little bit more bracing to keep it down, because that little bend needs to be just squashed a bit more. Then you can have another biscuit in, and if you're using a machine, you've got to pull everything apart, and then you've got to make another slot on both sides, and then you've got to put the biscuit in. But if you made a groove, it's just a case of opening it up and slotting another biscuit in and closing it up, and voila, your problem's solved. Does that make sense to you? Okay, so that's one of the reasons for using a slot cutter with your router. Okay, the other thing is you're guaranteed that that slot is perfectly 90 degrees or parallel to the face of the board that you're working with. Okay, that's one nice advantage. So, but there's a downside, as you can see here. A router can only slot along the edges. It can't slot in the middle of your board. But is that a problem for you? If your smallest bit in your little kit that you've got is 3.2 or 4 millimeter wide, and I think it is, why don't you just put a straight edge and put your router bit in it and then just run it down and just set it to the depth at the half of the 20 mil thick, which I think is 12.5 millimeters. So set it to 13 and just route a slot on the edge, on the face of the board, and then you can get your slot on the side of the board with your machine, and then you put the biscuits in and just drop them down. Does that make sense to you? You've got the bit to do that. So it can, in fact, do the face. You just need to be clever about it. Okay. Most slot cutters cut slots at about 12 millimeter deep. There we go. I normally make mine 13. Okay, so I've got stop and play. That suit the number 20 biscuit. That's the big one. And if you want smaller biscuits, you buy a kit that includes 3 bearing sizes for the 0, the 10, and the 20. So now you'll know why I showed you that bearing a little bit earlier on, because those bearings can be used for your slot cutters as well. So in this case, you've got the rebate cutter, and then you get the slot cutter, and you can use the same bearing on that. So now you're saving quite a bit of money in the long term, okay? All right, so that's a nice little feature to have in place. And I think for some of you guys, you're actually surprised to see that you could use a biscuit with the router, okay? So you don't have to go run off and buy yourself a Torcraft machine, a machine for 1,000 Rand, which is not going to really be all that steady and easy to work with. Or you can get an expensive one at 3,500 to do the same thing. Yeah, you've got your router that can double up for it, okay? Yeah, no, sure. So just, obviously set it up properly, okay? And make sure that you're happy with it. So yeah, that's a perfect example of how you would do it, okay? But over a longer width. But you know me, it's 12 o'clock at night, I'm tired, I'm trying to get things done, I'm always committed, and I will exit straight out on the other side. Okay, and I look at this and I say, you no. Now look at this, I've got no exit here, no exit on this board, no exit on that board, and this is the last one I've just exited out on that thing, and I look at it and I say, oh, come on, you're kidding me. So what do you think I do? Tell me. What do you think I do? Eh? Well, I can't cut it off. I'm going to join. No, so what I do is, and it actually works out better in the long term, is I then just put the slot cutter back in the exit, exit, exit. And then all you do is on those ends, just get a different colored wood, a darker colored wood, and just sand it down. And then just slot it in, and it looks so nice between the joints. It looks like a feature. And the client says, wow, that's awesome. Look at those little pieces. My mistake, your bonus. So do you understand? So that kind of works out nicely for you. So like I said, you can always fix your problems up in woodworking, okay? To a fairly good degree. People say limited. I don't agree. Okay, just a tip. Use the slot cutter mounted with an arbor equipped for the pilot bearing. And you can do it. I mean, I've gone down to 12 millimeter thick wood, okay? Just watch out what the application is, okay? You have some crazy scenarios that play out sometimes. The walls aren't too thick now. That means they can snap quite easily because you've taken away a third. So if in this case, you're 4, 8, 12, 16. So you, about 5 millimeters, you would be on either wall, 6 millimeters. So be careful. Might weaken the walls on the top and the bottom. Depends what, if it's a top that's going to stay still, you're good, okay? If you're trying to join things up for a box that's going to be moving around, not a good idea. So 16 mil and up would be safe, okay? But you work it out, gauge it. Right, okay, so to plane a straight edge. Now, here's an interesting one for you. Let's just look at the bit to start off with. This is called a pattern bit. It's got a bearing at the top, and the bearing over here is the same diameter as the cutters, okay? So if the cutter happens to be a 12 millimeter diameter, the bearing will be a 12 millimeter diameter. Now, when you want to laminate a tabletop, join them. It's called lamination. You need to make sure that those two faces will marry without a gap at the top. In other words, you don't have V's or that. Okay? You want to have that. The two faces must mat together. Now, you would turn around and you look at all the social media stuff. You see the guys putting the stuff through the table saw, and you look at it and you say, but I don't have a table saw. And then you'll see the guys will put this through a machine called a planer, which they call a jointer. And yeah, that works. Except that you would need a battleship-sized planer if you're doing a 3-meter piece of wood. Because how the heck are you going to get that through on its edge? So you've got to run it up. So what a planer is, it's got two beds that are, they normally co-planer, but you move the one bed down so that you can ride over and make sure that this edge here is 100% flat to run on that edge. So it's got a little bit of a step, about 1 millimeter in it. So now you're trying to push your 3-meter length through that, okay? It doesn't always go that well. Trust me, it doesn't. You need a big machine, you need help and all sorts. It doesn't work. And then you can't put it through the table saw because who's going to catch it on the other side, okay? Now you've got to build a contraption to catch it. But now what happens is it's so heavy it actually starts hanging over and it's now dragging, and you've got to try and force it down, and it's a nightmare. And the board starts curving so it doesn't hit that thing, and now you're stuck halfway with this whole thing. You know what? So that doesn't work. And then you look at what other options you can use a bandsaw, which is pretty successful in some cases, not always. And then you can try two other options. So the one option that I use, and it's a common option in my shop, is I take a track saw. And the track saw's on guide rails. And I put the track saw down, and I just cut, Bubba. I just cut. And those two faces mat together, and I'm happy with it. But sometimes I get a job where I know that I need to do things, and the wood is a different type of wood, and it's a little bit complex. My track saw, there's always toe out on a track saw. That means the back of the blade will make little blade marks, and because it's hard wood, I will definitely see that once I put the two parts together. And if that happens to marry on opposite faces, there could be 1 millimeter to 1.5 millimeter gap, and don't think glue is going to solve that problem, because it doesn't. So the only way I can solve that problem is by using a router. So if you don't have any of the toys that I've mentioned, but you've got a router and a straight bit with a pilot bearing or a pattern bit, and that's going to put you back about 450 Rand, okay, which is far cheaper than any of the machinery I've just spoken about, then you can use that. And remember my comment, the machine that is the most accurate in terms of your 90 degrees in your shop is your router. The base of that and the bit are perfectly 90 degrees. So when you put the base on the board and the bit is on the edge, you're going to have a perfect 90-degree face. So there's none of this nonsense of having to, oh, I've got to rotate and flip and all sorts of hokey-pokey stuff to get the place. So in other words, when I cut with my track saw, it'll cut at that angle, which means the opposite face is going to be that angle, which means I must take this one, flip it over so I can cut it at that angle. So when it comes back, it's sitting like that. I've got a trapezoid. So these two parts, no, none of that nonsense. You just have to do the faces and get the job done, as long as your faces are flat. So put it down and do your edges, and then it's flat. That will give you the perfect matting faces with glue in it, and the perfect with no holes or gaps or joints or spaces or anything in it. Does that make sense to you? And the router is going to do that job for you. However, you will need to use that bit, okay? And in order to use that bit correctly, this is what you need to do. So you would take that pattern bit and you would run it against an edge with a guide on it. So here's the guide. Can you see that? And there you can see the piece of wood that you're trying to edge. So there the bit is not, and this is normal, the bit's not long enough to go all the way down to the bottom, because you get 25 millimeter thick, you get 35 millimeter thick, you get 38 millimeter thick, you get 45, you get 50, and you get 60. So that means you need bits to get down there. The longer the bit, the more you need to go in diameter to keep the thing steady. So that means you need a 1/2 inch router to manage this, and a 50 mil bit to manage that process as well. Do you understand? So it gets more complicated. The more complicated your project, the more complicated things get. But the solution is you run that bearing against this bit, this edge here, because that's straight, that's your guide. And then it'll cut that part over there. Now, if this part happens to be too thick and the bit is too short, there's a solution for that. What do? It's actually quite simple. You take away the guide and you use the edge that you cut. Can you see your first edge that you cut? That will become your guide for your bearing to go against, and then you cut the remainder of the bottom part out. Does that make sense to you? Okay. And look, the guide can be anything, as long as it's straight. So for us, we're quite fortunate. We can get those straight edges that the builders use, those aluminium straight edges. You get them in different lengths, I think from 1.5 meter all the way up to 5 or 6 meters in length. You get yourself a 3 meter one. Maybe you get a 3 meter and a 2 meter for the shop. That's your straight edge. Only thing you just need to be careful is a little bit of flex. Okay, but if you pick up any flex, drill a hole and put a screw in there so there is no flex when you're working with it. Okay, so it doesn't move out or curve or bow or whatever. All right, but that's the process that you would need to do. So for your second pass, if you need to, just use the existing edge that you've created. And if there's a third one, just go down and do the next. Does that make sense to you? Okay, so that will work 100%. So, and there's nothing better than those edges. There's nothing more straight than that. So you don't have to get fussy. You just need to. So sometimes you can also push it through your router table. Okay, if you do the fences on your router tables, you've got your 2 fences. I'm going to just show it to you, and the bits in the middle. So what you would do is you would just drop this fence a little slightly back, so it's acting like a planer or like a jointer. Remember the jointer was working in that motion? You've done the same thing with the fences, and you've got your straight bit. So your straight bit's actually doing the same process. And then you can push your pieces of wood through that, and it'll give you the straight edge as well. You can do that. But then you need to make sure that your fence is exactly 90 degrees to the base of your router, or the top of your router table. Okay. All right. So I hope that helps you, because that's, I mean, I've known guys that have done this training and they've come back and said, gosh, that just saved me. I made a small little table and I used that to do the jointing. Okay. All right. So then another little trick is to flatten the bowed surface. I mean, we saw this hint a little bit earlier, but again, you just use a regular straight bit. And then what you would do is you would make yourself a little contraption like this. Now, yeah, you take the picture because it's actually quite interesting. I'm going to talk about this with you. Do you see these 2 little rails or fences? Can you see this? You should have that in your shop, irrespective. Okay? So for your juice groove, you would have 4 of those. And then what you would do is you position one up like that. This one overlaps there. This one overlaps there. And this one knocks up against that one. And then you put your board in there. You take spacers. You set the spacers up again. Then you take your router. You start over here. And then you move it around. And as you hit that corner, it'll naturally make a little round bit for you. But you make sure that you travel with the round side of the router, not the flat side. There's a flat side and a round side. As long as you keep that in contact with the fence, you can steer that through the corner. And then once you've gone all the way around, you've got your perfect juice groove. So how much did I saved you? 1,800 Rand. Are you okay with that? All right. So go and try that, because then you can take the same fences, and then you can create a little stretcher or a crab, if you want to call it that, so that your router can move up and down. There's the wood you want to flatten because it's too big to put through a machine. And then you can just use little blocks of wood as a clamp. So what you would do is look like a square, something like this. Just get the idea. But it'll just be a little bit bigger. You put that on the corner and screw it in so it holds that block of wood together. Okay. You might need to put wedges under it to level it as much as possible. But then once you've got that, just put wax on the top of the rails and then on the inside of the crab, and you can move it up and down. You can flatten it, or you can go and buy that woodpecker one. Okay. Okay. But I've got that. Does that make sense? That will size up. Mine are about 1 meter in length. So when you put one here, you cross the one over there, you cross the one over there, and this one crosses over here. So that means you just need to pull this one back to pull that one down, to push that in, to push that up. And then you make spacer blocks that go around. And those spacer blocks are the even edge where your groove's got to be, will allow the center of the bit to move that far over onto the board. But you create different spacer blocks. That's all you need to, that's the variable. Then you push it all together, clamp it all down. So you keep 2 parts clamped and that part side loose. And so when you loosen it off, you can take out the board. And in fact, you set it up that it's a friction fit, so you can just drop the board in, okay? And then when you finish, you take it out. Then you run around and you make your juice groove. Just keep the router intact with the edge. Yeah. Yeah. Yeah.
Can we get those in South Africa? have to worry about the flat between
Look, for most part, okay, so I'm just going to show you quickly. Triton came out with complete round, okay? Bosch has always had that. What is the reason for that part? So it doesn't roll off the table. And then what Bosch did was quite clever. The two handles lie flat. You've got 1 point, 2 point, 3 point, so there's no rocking. Now you can open up the flap and loosen your bit. That's what it's designed. It was only designed for that. So then if you look at the other ones, it's just variations on the design. So if you look at the Makita, this is the dovetail one. It's round all the way. Oh, no, it's not. There's a flat spot there. But again, put it flat. There's your lock for your spindle. And now you can change your bit. Does it prove the point? It doesn't roll off the table. So the Triton will roll off the table. Okay, well, not entirely. It's heavy enough to, once you put it down, it'll stick to one of the handles. But you just don't want the thing moving around. But there you go. It's round all the way around. Okay, does it make sense? And then this one, this is awkward. It's got a round there and then two flats, but definitely not this for a juice groove. Okay, I wouldn't. Okay, that's the best one to go for. Okay, does that make sense to you? So before spending that money, I know where you're at. It's a toy. You want this toy. Listen, you want to get an upcut spiral bit, okay? Go buy that for 1,500 Rand and then be in heaven with those fences, because that's just going to do the job in the sweetest way possible. Yeah, plywood. Take whatever scrap you got in the shop, just cut them all even, join them up, and then you set them up. And then just make sure when you do your boards that your router, once it's on top of it, actually bumps up against the side. When I first made mine, the fences were too low. So then all I did was I just took the bottom ones off before gluing, took the bottom ones off and I just lengthened them and then just flipped it around. Okay, so this is a little bit longer than that one. So for two scenarios, if I do have them, okay. Yeah, that catches you. Who did the bright plunky with me? Anybody? Yeah, it's exactly what we do in the bright plunky. The same setup. I bring them from my shop and I set them up here. Easy enough to do, okay? So get 4 pieces of wood and play around and see if it works, okay? And it can be used for a myriad of things. Absolute myriad, okay? All right. Smooth cuts on complex shapes. Okay, so, you know, this is a common thing. If you kind of doing woodworking, you've seen that a Durandac chair. Everybody knows the Durandac chair. And there's guys that are selling the Durandac templates that you can purchase from them. The templates are about 6mm thick MDF. Then you want to cut out that pattern on a piece of wood. Or maybe, you know, like myself, if somebody comes and says to me they want 8 chairs, I prototype 1 chair out of pine, and then I cut the templates for it. And then for the other 8 chairs that I need to make, I use those templates that I've just made from the prototype, and I use that to make repeat cuts all the time. Okay, so we set that up, and this is something, again, that you would use with a pattern bit. So if it materializes as something like this. So yeah, you can see the pattern is at the top, and they've screwed the pattern, and then they use the pattern bit that rides against that edge of the pattern, and then it cuts out the remainder of that. Okay, now if it's a problem, the material's too thick, what do? You've got a choice. You can either take the template off and then cut the remainder, or you can flip it over, because you can get a bit that's got a bearing at the bottom, and then you can use it that way. So number of solutions to the problems that you have, but there you go. So that could be for a particular project, and they need to make 10 of those things, and there's the pattern that they do. Now, interesting enough, in Jeppe, when all the furniture manufacturers were there, if you walked into their premises, you would have seen hundreds of templates standing hooked up on the wall with names and dates and all sorts of things on it. And they were all bundled together. So when those businesses shut down, people bought those templates that are worth an absolute fortune in their hand. And now, because the mid-century stuff's becoming fashionable again, suddenly it's starting to spear up in this. Little 2 youngsters down in Cape Town, they got the templates from their dad. And they are rocking at the moment. I look at the stuff and I say, oh, well, you know what? You get your bum in the butter. That's what you get, eh? So they got the templates, and they're running like little kings making chairs, eh? So they're doing well down in Cape Town. So awesome. Good for them. But you get the idea, okay? So that's what you can play out. It's the same as buying those Rocklet template kits for a chair or something like that. Try and find out if there's a local guy who bought those templates and he's making them, and he'll give you those templates for about $500. And then you can go and make whatever you need to. And then you're supporting a local oak on his business, okay? Sometimes I buy the templates just to support the guy. I've got these things in my shop. The other day I looked at a Durandac, the original Durandac. I still got it in shrink wrap, eh? I've never taken it out because I've made a Durandaks before. I don't like the chair, I must be honest. But they are the most comfortable chairs, funny enough. But I bought it off this old pensioner. He made all these templates, and it's still in the original packaging, everything, and I just never made one. I don't like a Durandak. I don't like the style. I really don't. I'm a chair man. You get leg men, and you get chair men, and you get top men, and all of that. I'm a chair man. I love chairs. But the Durandak just doesn't do it for me. But it's comfortable. I mean, I go to, if you go to the game lodges and stuff like that, they always got the Durandaks outside. They're so comfortable to sit in. But man, I don't want to own one. I seriously don't. I seriously don't. Right, crate trim easily. Here's another little hint for you. There's a round over bit with a bearing down at the bottom. That's in your kit, by the way. You've got a couple of those radiuses, okay? So you can use this to take and make a skirting. You've got skirting at home, and instead of going and buying the pine version of it, you've got a piece of solid wood somewhere, then make one for yourself. I mean, it's not a complicated thing. And true story, I had to do this for a client. They tiled up their bathroom, and they asked the tiler, please, it was in a complex, and the ceiling was obviously a concrete ceiling with that popcorn on it. And they asked the guy, please, can you cut the tiles? Because it had a bit of a slope. Just match them so they fit properly. And then the tiler disappeared. He came around to come and inspect it, and he looked at it, and there was these gaps, these step gaps. So he busy talking to me. He's saying, hey, these guys, seriously, you pay them this money, ask them to do something, they can't even get the job done. Now they wanted to fill it up with, the grout and whatever, and it looks horrible, okay? It just doesn't work for him. So I said, okay, I'll tell you what, I'll do something for you. And I had a serious piece of plywood. I just finished a plywood project. So I cut a profile on it, and then what I did was, it was about that wide. So I said to the guy, I could just take it with you, because he's got a contractor saw. I said, just take it with you and just trim it to the thickness that you want for the top. And then he sent me a picture and said, no, it worked perfectly. He didn't even cut it. Stuck the thing up, plaster primered it, put no more nails on the back, stuck it up on the wall. You know what plaster primer is, eh? Yeah. And then he painted the damn thing. And I spoke to him the other day, and it's about, 10, 12 years later? It's plywood in the bathroom. He says it's still ticking. Nothing wrong with it. It's still working. The secret was the plaster primer. Okay, so there you go. That's how you do it, okay? So take a piece of wood, put your profile on it, and then you cut that little quarter round off. Okay, does it make sense? Now you know how it's done. And you were thinking, oh gosh, it's too small and whatever. No, don't worry. That's how you do it. Okay, does that make sense to you? But then again, please don't do OGs and Roman OGs for your profiles at home. It doesn't work. That stuff just gets knackered, eh? Why do they make them round as a matter of interest? Anybody know? So if you have a square edge, you can actually put your nail in there and dent it. Put a round over on it and try and dent it. You can't dent it, okay? It's just that the roundness just makes it more firm, okay? And it's exactly the same thing. So now your vacuum cleaner and the kicking and the scuffing doesn't break the square edge. It's round, so it either rides up or it takes the impact. So that's why it's a quarter round, okay? Hello. 3 millimeter diameter, yeah. 3 millimeter radius, yeah. Yeah, you can get them. With the bearing, yeah. You can get without, but then you've got to set it up. You've got to jig it. I'd rather have it with the bearing because I'm going to ride it up against an edge. Okay. Yeah, I know, 3 millimeter radius. Smallest one. Okay. I normally use a 6. Yeah, and now we call it pencil. We inherit the name from the granite and the marble guys because they put a pencil around the granite. So now we put a pencil around the wood. Call it a pencil. Oh, okay. Oh, okay. All right. Yeah, no, sure. Yeah, look, you do adapt things as you need them, eh? You really do. No, good. Okay, repair and reinforce cracks. Okay, so say, for example, this example I'm just going to show you. You've got a chair and it's got a crack in it and it's now full of crud and all sorts of nonsense in that crack, and now you want to fix it up. So you try and clean it out and you get yourself no more nails as you do, and you put it together and you try and clamp it, and it works for about a month, and then it cracks open again, and then you come and see me, and then you get all iffy with me and say, you fix it, and then I've got to fix it. So I'll fix it for you. This is what I'll do. So I'll take the seat, and then I'll, first of all, what I'll do is I'll clean out the crack as much as I can, and then put some glue in and clamp it up, and then I'll route out a gap in there, and then take a piece of board or perfectly ply, and then drop that into that crack. When that's dried, there's no way that crack's coming back. I can guarantee you that. Not in a million years, okay? All right, you get the idea? Okay. Real life situation, eh? Do it quite often on these chairs. All right, cut perfect arcs and circles. We always want to do circles with our router. And I told you I did mine this week. But you know what? There's a little bit that does the trick. It's called a spiral bit. It comes in an upcut form where it moves the chip bits or the bits, the chaff or the sawdust. It pulls it out of the wood. It's called upcut, so it pulls it out. And then you get a downcut where it compresses it into the hole. But normally a downcut should be used when you're doing an edge. Okay, so in my case, I used the downcut because I had the face upwards and I didn't want the upcut, otherwise it would splinter and chip. So to mitigate that, I used the downcut spiral bit so that it'll do it and the back end gets knackered. But I was going to put a little 6mm round over anyway on it, so that would be fine. So this is what I use. Now, these bits are expensive. Okay, you need to know people who know people to get that at a very good price, because the one that I bought the other day was 3,200 Rand for my 10mm. It's a 75 long, but you know what? It's a sweet toy. It's solid carbon. If you drop it, it chips, and you can throw it away. So don't let anybody near that stuff. Don't even let your kids say, "Oh, Dad, what's this?" Kill them, man. Say, "Don't touch. Poisonous." No, it won't. Okay, you know how it goes. Okay, so again, don't use bits that are smaller than a 10mm diameter. Okay, so mine was a 1/2 inch. Okay, so that's 12mm and bigger. And it's the sweetest bit ever, man. Gosh, it just makes your life. It just slides through wood like it's butter. Yeah. Yeah. Yeah, so you can get them in 1/4 inch. Okay, it's advisable that you don't, because it's solid carbide, tungsten carbide, so it's brittle, so it doesn't have that strength, so it can snap. They advise you not to do that. I've got bits that are that small, but then you must just dial down the speed a little bit. Just go slow. Don't push. If you start pushing on this, it's going to snap. That's why the CNC guys use those 1/4 inch and 3 mils. You know what? I don't want a CNC machine. I hand the stuff over to the bloke. If his bits break on him, that's his problem. I asked him to make me that, and I want that, and that's what I'm paying for him for. So when you want to know why they're expensive, it's because they're building in the cost of the bit into the project. And because I know that, I go to my guys, come on, you're plugging me. Stick your bit, man. Here's my bit. Use mine, or whatever. You make a deal, and you get a good price on it. Okay, so don't negotiate. Always negotiate, but they do. They charge you literally the price of a bit. Oh no, those things break, eh? Gosh. I've stood there watching them doing a job for me, and the bit broke on the guy. And I know the bit's 1,500 Rand. Sorry, my mate. Not my problem. Oh, well, that's my profit gone. Oh, well, that's how you run your business. All right, we have a question. Thanks, Colin, my mate. Appreciate it. I'll chat with you later. Okay. All right, so that's how you can do arcs and circles. Is use a bit like a. You can use a normal straight bit, okay, with the two flutes on it. That's going to be perfect. But this is to really get a nice professional job without any burns and headache and whatever. All right, so here's a bar table that needed to be made, and the guys made a makeshift trammel. So there's the pivot point. So these pieces started off as rectangles, and then you would laminate them all together and joint them. And then what happens is you take your jigsaw, because you get nice long blades, 150mm long blades, and you trim off as much as you can with your jigsaw. You try and get as close to where you are, but be careful. If you're not good with a jigsaw, you've got to practice on it. When you're moving forward, the blade bends, so it tends to cut that way. So don't cut upside down, eh? I've seen guys cut upside down, and they want to know why is the diameter now smaller. Okay? Cut the face. You have to ride on the face, and then make your cuts. And please don't sand before you're done. You finish with your jigsaw, because your jigsaw will leave marks on it unless you put something down at the bottom of it. I see guys are saying, "Oh no, they put Teflon and all sorts." I think, "Oh gosh, sand! I've got to sand it anyway." So, all right. So yeah, they would use a proper nice bit with a trammel, and then they would go around and cut it. And then the router would be attached to it with the bit poking through on top of that trammel, and then you can go. It's relatively easy. There's no drama on that. If that was a proper circle starting from one end to the other, that's where the trauma comes in, because now you've got to plunge into that. And there's a little bit of wobble, so you always get a little notch that gets created. And you know you've got to take that notch out at some point, okay? No drama, but it's got to come out, okay? All right, does that help you? Anybody? Somebody? Okay, I've spoken about this, how we break the square edges on a board or a table or whatever the case may be by using a round over bit. Okay, so there you go. All right, easy enough to do. I've got a router that's permanently locked with my 6mm bit in it, set at the correct height, and all I know is it's that if you can remember the first slide in the presentation where I showed you what was coming for July, there was a little router next to it, a little funny looking router. That's my router with that round over bit in it. It's locked and set, and I put my battery in on it, and then I run it around the edge of the table and run around wherever else I've got a round over and clean it up, put it back in the box, take the battery out, recharge, pack it away. Okay, that's all it gets used for. Should you leave the bit in your router? No, never. Why am I doing it? Just because I can. No, it's locked. I'm used that router so much that the switch is actually packed up. So I've got to get it in for a service, and then it's got to get opened up. So I don't know what's going to happen to the collet. Maybe I should replace the collet. Okay. But you know what it is? To set it up on that round over every time, it takes time. So if it's locked in, it's in its box. You know that when you take it out of the box, it's going to work 100%. I'll just quickly put it on a piece of scrap, make sure there's nothing wrong. Always test it, eh? You never know. My daughter's with me in the shop, and she could just dial it in one direction, and I've got a headache. Okay. Does that make sense to you? Okay, so it puts a nice little round over. So the tables we've got here have got the round over. So here they show you the router putting a round over. And a very nice little tip. Do it at the bottom of your door when you install your doors. Why? Because then it doesn't snag and catch on the carpet. That little round over will be nice and smooth. Yeah. And it does the job, eh? Yeah, I never thought of it. Those hollow core doors, put a little round over it and watch how, you know the new hollow cores, the minute it snags on the carpet, it rips the hollow core off. Eh? Yeah, so put it round over and tell the guy, quickly, can you just pop a round over on that thing before you install it? Huh? And he explained to me, he said, oh, that's clever. Eh? Well, that's another $50 to do that step. All right, so Nick Offerman, you should all know him. Why not? No? Parks and Recreation? No? Seriously? Okay, so he's a TV actor, but he's got a woodworking business, and he gets involved in woodworking and so on. And that was what he looked like after one of these river tables, he'd flattened it, and that's what he looked like afterwards. Don't worry, you'll look like that as well. Okay, so there we go. All right, so for advanced routing, there's 3 other routing courses, just going to push them a bit so you know if you're keen on anything. There's a router level 1, so that's the basics. We put you through the practical, show you how to fit the bits properly, tighten everything up, set everything up. You try the different routers, bring your router if you want to, and then you run with it and play with it and try things out and just get your confidence built up. By the time you finish that session, you'll be confident. Router level 2, we'll do circle cutting, template routing, which people are very interested in for the most part because they want to know how to set up something as a template. So we give you a little shield to make, and then you can use that as a template back at your shop to make other shields, okay? You can put a name on it and whatever. And then there's one thing in terms of routing. There's people that I know that can do freehand routing. There's one thing that I just never do. Yeah, watching a guy the other day do a fairly big mortise, freehand. Looked at it and I thought, geez, when I do that, it just goes all over the place, and I just give up, man. So I jig everything. I just jig it. Jiggy, okay. Router level 3. Okay, so that's the dark science of routers, that particular course. It's where we talk about using guide bushes. Okay, now you're looking at me seeing guide bushes. So just give me a minute. I'm going to see if I can get one for you. Sorry, my mate, I just want to get past you. If I can find it. Okay. All right, so in your router kit, like I said, you get a whole bunch of gadgets. Now this little gadget over here, you get something that looks like that. You've seen something like that. It's a round disc. It might not be sort of jagged like that. It's round. It's got a little knobby that sticks out like that. You've got that in your box. You've all looked at it and you thought, you left it in the box. Grab it and just send it around so everybody can have a quick look at that. Yeah, it's called a guide bushing. Now, I want to just, I'll tell you quickly what it's all about. You know what, you've just built a beautiful walnut table for a client, okay? And the client says to you, it's for his office. He's a CEO of a big company. You've just finished building the table for him. You've got everything set up, the drawers and everything, all the fittings and fixtures. It's a top-class product you made. The guy comes to you and says to you, you know what, can you do me a favor? Can you do some cable management cutouts on the top for me? And he's paying top dollar for this desk that you've just made. And then the reason why he's asked for this is because he had a look at the Fortune magazine and he saw one of the bank CEOs who had one in the United States and he wants that, okay? Now you've just built this thing and it's a lot of money and he says to you, he wants a little cable management system and you think, yeah, all right, okay, we'll put that in for you. So the easiest route is you zip off to Galmar, you go and buy a plastic 35-buck one, you cut a hole in the walnut top, you drop it in, you put some, again, no more nails, good product, stick it in, clean that off afterwards, and get one that matches what the color is and plonk it in. He's got this plastic cutout with that little plastic cover, and you give it to him. 9 times out of 10, the guy would probably be happy with it, but would you be happy with it if you're a decent craftsman? No. So then what you do, you create what we call a plug and hole, okay? So in order to create the hole, you need to use a router. I'm not going to use a hole saw. That's not going to work in a million years. You know enough what a hole saw can do, okay? It's only to make a hole in something that's going to be covered by something else. That's all it is. Otherwise, if you're using it as a professional tool, then I don't know what you're doing. But you're going to make it with a router. Okay, so it means you need to make the hole. And then you need to make the plug. So there's a little bit of maths involved in there to how do I make this hole so this plug fits in. So in this scenario, I made the hole, which is easy enough, but then I made the plug out of maple, and then I made the little cover where the cable comes through. Again, a plug and hole with a little ridge. So you could put that little piece, and that was made out of walnut. So the maple was the actual piece that went in just to break the contrast. And I made that, and I did that whole thing. So in order to do that, I successfully achieved that by using that guide bushing that you guys are busy moving around. Except they come in a kit. This is a 17 millimeter diameter. I don't know why, but they always put a 17 in the box. No idea why. And I've asked the suppliers. Everybody else, somebody started with 17, so we all put 17. But you get them in different diameters, and the diameters that can go up to 40 millimeter in diameter, 30 being the most common. So when you're looking at, these bow ties or what do they call them? Butterflies. The butterflies that they put on a table, again, they call it bow tie. Butterflies. Those butterflies are plug and hole. So you get a template where you've got to use a bushing to make the hole, and then you've got to use a different bushing to make the plug with a different size cutter. That's the plug and hole. This is the dark science of routing. When you start learning how to work with this, then your game is up, and then or up there, and now you're starting to produce stuff, and then you will do this. When I did that and I delivered it to the guy, he wasn't there, he was away, and then when he got back, he phoned me and he said to me, "This is the most," he said, but all he could talk about was that cable port. That's all he could talk about. He said, "How did you do that?" So I said, "No, you're going to have to pay for this." He said, "No, how much?" I said, "No, it's a dark sheet. If I tell you I have to kill you, I'm not going to tell you." He said, "No, I'm being dead." He said, "I don't care his position." He's a big up guy. He said, "Man, he says, I've sent it to all my mates." So I got extra tables from his mates because, CEOs talk to CEOs and play with each other. I mean, golf and stuff like that. And they could. And yeah, I've got a couple of orders back of that, just because of that cable management report that I did out of solid wood, and it was a proper done job. So not really. It depends on what you get. Have a look at the Milescroft kit. That's why I'm saying to you, go for the Bosch solution, because Bosch have got the thing built in already. It comes from Porter and Cable. They standardized on it. So it's a standard on any Bosch router. I pulled it out of that one. So it'll fit in there straight away. And then all you do is just close it on there. And you buy the Bosch kit with a Bosch router. It's already got everything that you need. If you don't have the Bosch thing, then you're going to have to get adapters for your routers, okay? Then you're looking at about another 400 Rand on top of the bushings. But it's worth its weight in gold and money, okay? Honestly, I wouldn't look back. I honestly wouldn't. Now that I know how these things work, it's just, I sometimes say to myself, should have known this in the beginning. Nobody showed me these things or taught me. I picked this up as I went along, or saw somebody do it and asked them how, and they said a bushing, and then researched it and then worked out how these things work. So that's the secret. This is the dark science. So that's what level 3 will do for you. Then I'll show you how to calculate it, and then you can go back and then set this up yourself to make whatever you need. And there's many scenarios, So again, I mean, a guy was telling me yesterday, he says to me, I know my mate's got a crack on the end of his table. I'm thinking, why has he got a crack on that? Because let me tell you something. When you buy a board and there's a crack in it, wherever the crack stopped, it's not going to go further than that, and it won't crack again because it's supposed to be kiln dried. It shouldn't crack again. If it does crack on your furniture, it meant that the guy got wet wood and he cut off directly on the end to be frugal and save on material, and he gave it to you, and you've ended up, or they may have glued it and the cracks burst open again. Okay, so never ever do. And in fact, if you go to the timber merchants, they will never sell you the board length with the cracks. They'll normally come into where the cracks end, and then those are the part you only pay for that section there. And if it's a wide board and you can actually get a nice long piece out of it, well, that's your score. Do you understand? We've got to win somewhere. Okay, but do you understand how that goes? So please, when things like that happen, there's a bit of dodgy going there. Okay, that's that story. All right, let's have a look and see where we're at. Okay, so there we go. So that's the other 3 courses. Please have a look at your emails and then see if there's anything worth or something of interest for you. Okay, all right, any questions or anything at the moment? Anybody wants to know anything, ask anything? I've got no money, so let's set that aside. Yes.
I want to round that piece of 50 by 50. Like me. I want to do it the round of whatever you want. How do I hold it?
Okay, so the question is that, yeah, the question is, I have a piece of wood that I would like to route, but the wood is about 50 by 50 millimeters square and about 20 millimeters thick. How do I route that piece of wood? How do I hold it? Well, you hold it carefully in your hands, and then you use one of the small routers and you move. No. Okay, you can use a table router. No. Okay, so what you do is there's this magic invention called double-sided tape. Okay, so what you want to do is you want to put double-sided tape on the backside or whatever you decide is the backside, and then you mount that onto a piece of melamine which is clamped to your table. Make sure that it is pretty sturdy, and then take your router and then slowly work your way through it. Okay, no guarantees. Or if possible, if you can get a screw underneath it to lock it down, that's another way to do it. But last resort would be double-sided tape. Okay, if you can try and screw it in, but yeah, I get where you're coming from. But then you should, yeah, it's racing through my head what solutions you could use. I was thinking of using a lathe, but that's not going to work for this in practicals. You now have to glue a stem onto it or something to hook it in. So it gets complicated. But yeah, so double-sided tape. Now listen to this, okay. You know, social media, they talk about this painter's tape and then the CA glue they put together. You've seen that. Why? Go and buy a roll of Scotch 3M double-sided tape. $150 somewhere around there. That's South African bucks. It'll last you forever. I promise you. I've had my roll for about 10 years, and I took it out the cupboard this week because I had to put that plaque down because I didn't want to put any holes in anyway. Same scenario as you. It was big enough for me to grab, but I just wanted to get everything done in one shot. So for the round over, so I just put 2 strips of double-sided on melamine, clamped that down, and then just ran the router around on that. That was fine. It was perfect. There was a little bit of movement. Little bit, but not enough to make me concerned, okay? Because, you know, it's kind of big enough to do that, the centrifugal. But, yeah, double-sided tape is cheap enough, and you can use it for 1,000 things in the shop, okay? Get a wide one, a band about an inch, 45 mil. No, yeah, they've got. I bought my roll, yeah, from ages ago. And the stuff stays pretty fresh. It's never gone off. So use that. And then, of course, if it's, you know, when you want to use it, you can cut little strips out like that, or you can cut a long strip and put it down. This stuff works. Sometimes you've got to get a scraper blade underneath it to try and pry things apart. But it's worth the effort. Sorry, I'm going to come to you. Is that your, okay for you? Answer? Yeah. Say again? Oh, the hot melt glue. Yes, you can also use that as an option, okay? But test it on the wood, because when you pull it apart, it pulls those fibers out. And you might just have it at the wrong fiber angle, and then it's going to make a bit of a decent tear out for you, okay? Yeah, no, hot melt is also, that's another thing. Keep a hot glue gun in the shop, eh? So many times I tack stuff down just to hold it temporarily before moving on, okay? Yeah. There's also another thing with hot melt. If you're clever, you can get different colors of hot melt that you can use instead of having to mix epoxy to fill up knots and holes on a tabletop or something like that. And it works well, and you can put your finish and whatever over the top of it, okay? Easy enough. So have a look at that. There's a company down in the Cape that sells it. You can just have a look around on the internet. You can get that as a hot melt. Any other questions? Anybody else? Right, folks. Okay, good. That's it. So thank you for attending today. I really appreciate it. And for the folks that are online, thanks for joining us. I hope it was something that you could learn something from. And we look forward to seeing you guys again. Right, have a good weekend. And that's me. Okay.